Good morning, friends. Good morning to this Maha Marathon of steel structures. Yes. So, welcome Alekhya, Swapnil, and other participants who are joining in. Yes. And welcome Nikki. Yes. And many participants, I'm sure, will be watching this lecture recorded. Yes. So, welcome to them also. Yes. So, let us start the session. Okay. Okay. Wow, so many participants. So, very nice to see so many participants. Welcome Minhas. MVS, Juhi, yes. Naividya, I am good. MVS, nice. Yes. So we'll start the session. Let me introduce about myself first. Many of you might be already knowing me. If you don't know me, then a short introduction about myself. My name is Satyajit Sahu. I have done my BTech and MTech both from IIT Kharagpur, and I was selected into many PSUs through GATE. Yes, so I've been teaching for GATE and EAC from last 10 years. I've also got a very high score in EAC interview, and I have worked in Delhi Metro Corporation as design manager. Okay, and then I have been teaching for more than 15 states. In more than 15 states, I have taught. Okay, and I teach all the civil engineering subjects. Okay, so welcome Samriddhi, Girish, Sayed, Anbu, Sai Charan. So nice to see all of you. Yes, that's a great morning then. Yes, welcome Bhumika. Yes, so great morning. So all of you might have taken your breakfast. Is your breakfast over? Is your breakfast over? Is your breakfast over? So all, if you are attending the class, then I feel that you should be a little energetic. Yes, little energetic. So uh, you all please have your breakfast so that you don't feel sleepy in the class or less energy. Yes. Okay. So I will request everyone to have your breakfast, or if you don't have breakfast, and have your breakfast while you're having the class. Okay. So let us start the session. Okay. So we are in this marathon series. Okay. So yesterday, many of you very enthusiastically participated in the SO marathon. It was a great session by Avinav sir and Dheeraj sir. Yes. And this is the rest of the schedule. Okay. This is the rest of the schedule. Okay. Like today, I'll be taking the steel structures. Okay. And then environment by Richa ma'am. Then geotech by Avinav sir. Yes. And then fluid mechanics by Joshit sir and Chandrasekhar sir. Yes. And then on 9th, we are coming up with this expected question series by all the faculties, a mixed session. What happens is that sometimes when you're studying only one subject, you see, we are studying one subject each day, right? So in between we should mix the subject so that we get acquainted of what? Mixing of subjects. So there will be a top 100 expected question session also, and then we'll continue with the marathon, surveying, structures, irrigation, hydrology, building material, CPM, yes, RCC, transportation. So all the subjects will be covered, and we can say that all the important portions of all the subjects will be covered. Yes, we will try to cover as much as possible, which is having the highest probability. Yes, so now time is less. Yes, the time is less, so we should study what? We should study those things which have highest probability of being asked in the examination, right? Highest probability of being asked in the examination. So we should be focusing on that. Okay, so we'll focus on that. Okay, so let us start the session without any further delay. Okay, let us start the session without further delay. Okay, so first of all, I will be starting with welded connections. First of all, we started with welded connections. In welded connections, what questions they will ask? Okay, what questions they will ask? They will ask you the specification of weld, strength of weld, yes, and then eccentric welded connection, combined shear and bending, and then eccentric welded connection, torsion. Okay, so out of this, these three will be more important, but doesn't mean that torsion they will not ask questions, but I will take more important, I can say. So let's start with the specification of weld. Okay, so first we'll see the size of a weld. So if you are welding two surfaces like this, and this is a fillet weld because the two surfaces are not in the same plane, right? So it's a fillet weld. So we'll be discussing fillet weld because questions mostly are from fillet weld. So when you're welding these two surface, okay, welding like this, suppose you are welding like this is the welding, weld done like this. So you see this weld being which you have done, it can be approximated as a triangle, right? It can be approximated as a triangle like this, right? And this is known as what? This is known as the weld triangle. This is known as what? This is known as the weld triangle, right? And we take this an isosceles triangle. So I can say this side length will be same. So this is S, and this is the weld triangle. And this is known as what? This is known as the size of the weld. This is known as the size of the weld. Now in examination, what they can ask you? In the examination, they can ask you the minimum size and maximum size. Objective 1 mark question they can ask you. So what is the maximum size of weld? Now first of all, to understand the maximum size of weld, where is that which type of member you have connected? You have connected two plates. You can see here two plates. It is called two plates, or it is also called as what? Square edge. It is also called as what? Square edge. So directly I have taken the provisions from the code. So these screenshots are from directly from code. Okay. So I will be discussing many of the things from code. Directly I will take the screenshots of the code and I have put it so that you also trust that whatever sir is telling is from code only, right? So all these are from directly taken from IS 800. So I will be showing you the pictures from IS code also. This is square edge. Yes, this is square edge, and this is what? This is round edge. This is what? Round edge. This is round edge. Now when we are taking the maximum size, you can see that we are welding two plates like this. You have to leave some minimum gap, right? This minimum gap is 1.5. This minimum gap is how much? This minimum gap is 1.5, right? And therefore this becomes the maximum size. This becomes the maximum size. And this maximum size depends on the thinner member. The maximum size will be how much? It will be, I can say, T minus 1.5, because at least 1.5 gap you will maintain, right? So this is T minus 1.5. T is what? T is the thinner plate, thinner member, I can say, thinner member. So understand this very important concept, that the maximum size depends on what? It depends on the thinner member. Opposite, I can say, right? Opposite logic, I can say. That maximum size depends on the thinner member, right? So this is for what? This is for your square edge, where we have what? Two plates connected. If you have an angle or channel connected like this, then what happens? Channels or angles. Suppose I am taking an angle. Angle is what? In a standard angle, suppose I am taking 100 into 75 into 8. That means what? This 8 is the thickness, and this 175 are what? Are the leg distance, right? So whenever you are, putting like this, you are welding like this, a particular angle, okay, then what will happen? You have to maintain some gap. So you have welded like this, you have to maintain this gap, right? You can see this gap is mentioned here. How much? This minimum gap. You see the minimum gap which you need to what? Maintain is how much? It is 1/4 of the T. It is 1/4 of T. This minimum gap is 1/4 of T. So 1/4 of T means the maximum size will be how much? This maximum size will be how much? This maximum size will be equal to your 3/4 T. Because you are maintaining gap of 1/4 T. So in the examination, okay, in the examination you have to be little careful, okay, that what they are asking. They are asking you the gap or the maximum size, right? Like you see in square edge, if I ask you gap, the minimum gap is 1.5 mm, right? The minimum gap is what? It is 1.5 mm. And here the gap is how much? Gap is 1/4 of T. Yes, the gap is 1/4 of T, and maximum size is 3/4 of T. So please don't jump in the examination seeing the question. Read that they're asking you the maximum size or the minimum gap, right? You have to be a little careful about that. So this is the maximum size. Now coming to the minimum size. Okay, rebates are not part of syllabus, so ignore that, forget. Okay, minimum size of weld. Like you see, maximum size was depending on what? It was depending on the thinner member. So minimum size will depend on what? Tell me in the comment section. Minimum size of the weld depends on what? Tell me in the comment section. It depends on what? It depends on what? Tell me in the comment section. So I'm just I can tell, just I want you to be little active. Otherwise, if I only say, then you will all sleep. Okay. Okay, very good. It depends on the thicker member. It depends on the thicker plate. or thicker member, I can say, right? Yes, thicker plate or thicker member, I can say. Yes, small things are very important. The small things are very important. Okay, so here you can see that when the size is between 0 to 10, so you cannot be 0, so I can say greater than 0 to 10. And what it is written, including, right? It is written what? Including 10, that is minimum size is 3 mm. Then 10 to 20 including 5, including 20, that is 5 mm. Then 20 to 32 including 32, it is 6. So if I say that the thicker member, if I say the thicker member is, if I ask you the thicker member is 20 mm, then what is the minimum size? Tell me. What will be the minimum size if I say that the thicker member is 20 mm? If it is mentioned in the question that the thicker member is 20 mm, then what will be the size? Tell me. Minimum size. Thicker member is 20 mm. What will be the minimum size of the weld? What will be the minimum size of the weld? Yes, it will be 5 mm. It will be 5 mm because you see what is written. It is written here including 20. So including 20 it is what? It is 5 mm, right? Including 20 it is 5 mm. Understood everyone? Yes? Yes. Now suppose the thicker member is not given. Suppose plate thickness is not mentioned. Plate thickness is not mentioned in the question. Then what will be the minimum size? You will write down in the examination. Plate thickness is not mentioned in the question. Then what will be the minimum size you will write down? Tell me. If thicker, plate thickness is not mentioned in the question. Is not mentioned, sorry, is not. Is not mentioned. Then what you will do? Tell me. Is not mentioned. Good morning, good morning, good morning to all. So if it is not mentioned, then you will write down 3 mm and then easily come back. No issues. Why? Because nothing is mentioned. So we will go for the minimum one, which is 3 mm. Okay? 3 mm. Understood? The minimum size and maximum size, right? Very good. So these two things, they can ask one more questions, right? They can ask you one more questions from here. So I'll request you, okay, that you remember this. Then there is what is this effective throat thickness. What is this effective throat thickness? If this is the weld triangle, right? If this is the weld triangle, right? So this is S, this is S. Now you see, there can be failure in multiple paths. There can be failure like this, like this, like this, like this, like this. Now when there are failures like this, right, it will try to find the shortest path, right? Shortest path is this one. This is shortest path, right? This is the shortest path. Yes? And this shortest path is known as what? The effective throat thickness. This is known as what? Effective throat thickness. The shortest path. So I can, the shortest path is the what? I can say this is the shortest path of failure, right? I can say this is the shortest path of failure. I can also say this as what? This is also what? I can say the weakest section. This is the weakest section. Okay, because the shortest path of failure, so the weakest section of a weld triangle is the weakest section of what? Weld triangle. Right? Now, what code speaks about it? That how to find out this throat thickness. Let us see what code writes. So we will refer to codal provisions regularly in this particular course. So the codal provision is telling that for the purpose of stress calculation, the effective throat thickness, you see the effective throat thickness will be taken how much? K times the size. K times the fillet size or K times the size of the weld. Right? And this K will be taken from a particular table. Now what is that table? The table is this one. Directly taken from code. Okay. The table is this one. So you can see that for the fusion angle between what? 0 to 90 it is 0.7. Yes. And after that you see 91 to 100 there is decrease of how much? There is decrease of 0.05. Again 0.05. Again 0.05, right? Again 0.05. So you can see the decreases are what? 0.05, 0.05, 0.05. So it's easy to remember. It starts with what? It starts with 0.7 and then you see there is decrease of how much? 0.05, 0.05, 0.05. Continuously decreasing by what? It is decreasing by 0.05. Okay. Thank you, Pankaj. Okay, decreasing by 0.05 continuously. Now, you have to remember just key things. See, 60 to 90 it is 0.7, right? Then you see the next you should remember is 100. Remember 100, okay? Or 106 you remember, okay? And you remember this 114. If you remember these three things, now you remember the range. You see how I've told many times. You see 60 to 90, okay, that is, there. I told remember 100. So obviously this is 60 to 90, so obviously this will be 91 to 100. So remember only 100. Yes. Then I told remember next one is what? You remember next one is 106. So if this is 106, so obviously this will be 101 now because this is 100. Yes. Then I told remember 100, your 14, or you can say remember 113 also, that is also fine. So remember 13, then what will happen? 13, so obviously this will be what? 107, 307, yes. And the angles are between 60 to 120. The angles are between what? 60 to 120. So if you see, if you remember these three also, you remember the ranges, right? Yes, the decrease is 0.05 only, starting with 0.7, right? So I can say that this fusion angle will be what? It will be between 120 degree to 60 degree. It cannot be less than 60, it cannot be more than 120 for stability, right? So let us solve some questions now, but before that, the actual length of weld. What is the actual length of weld? Now see, you might be seeing diagrams like this. Okay, you have seen diagrams like this. This is the plate and this is another plate, right? Another plate, right? So in the drawings, suppose they have shown the weld like this. In the drawing, suppose they have shown the weld like this, right? Now this weld which is shown in the drawing, that is the effective length. That is what? The effective length of weld. That is the effective length of weld. That is the effective length of weld, LW. That is the effective length of weld. So whatever drawing they have shown, that is the effective length. The actual length is little more than that. Okay. So how to find out that? Let us see. It is written that in this written, what is written? The effective length of a weld, okay, of a specified size. Okay. How we are finding that? Okay. But after that something is written, you see. The actual length of the weld is made up of the effective length shown in the drawing plus 2 times the weld size. So I can say the actual length of the weld will be the effective length plus 2 times the weld size. Yes, but in the diagram whatever is given, that we use for calculation, and that is directly the effective length. So in diagram you don't have to do any changes. Directly you can take that as for calculation, right? But if they ask you a question separately, what is the actual length? That is the length of the weld plus 2 times of S. And this actual length should not be less than what? Should not be less than 4 times the weld size. Or I can say it is, can I say should not be less than means what? It should be like this, right? Should not be less than 4S. Or I can say it should be greater than equal to 4S, right? Greater than equal to 4S, right? The minimum you can say actual length. Okay. So now based on all these things, let us solve some objective questions which they can ask in the examination. Okay. So let us start with objective questions. Okay. So first objective question, but again one more thing is that is area of weld. What is this area of weld? The area of weld is AW. That is simply what? Area is what? Very simple. That is LW into throat thickness. The effective length into throat thickness. That is give me what? The area of weld. Okay. Effective length into throat thickness. Okay, or effective throat thickness I can say, right? Effective throat. Good morning, Kavya. Okay, so now what I told, what you have discussed S, we have discussed S maximum, right? We have discussed S minimum, we have discussed the throat thickness, yeah, depending on the size, KS, then we discussed actual length, effective length, and then the area of weld. Okay, great. Okay, so finally first question. Answer this question then. Okay, answer this question then. I'll switch on the AC. Some problem happened. Okay, you answered by that time. What is the answer to this? Lots of water by that time. Answer A See, it's an angle section means what? Round edge. 3/4 of the thickness is the maximum size of weld. So this is the thickness. So 3/4 times of this, that is what I can say directly 7.5 mm. Directly 7.5 mm. 3/4 of your 10. Good. Next question. Thank you, Pankaj. Now, answer this next question. Read the question. See, it is minimum size. Minimum size means what? Minimum size means thicker plate. Minimum size means you have to see thicker plate. Thicker plate is which one? Thicker plate is 12 mm. 12 mm lies in the range of 10 to 20, right? That means what? The minimum size will be 5 mm. It will be 5 mm. So answer is this. Understood? This kind of 1 mark questions they can ask in the examination, right? This kind of 1 mark question they can ask in the examination. The next question. Okay, next question. Answer this. Minimum length of fillet weld of size 10 mm. Minimum length of a fillet weld of size 10 mm. Minimum length. I discussed this, right? What is the answer? Yeah, see, they are not mentioned effective length, what is actual length, and it should be greater than equal to 4s. So 4 into size, that is equal to 40 mm. Straightforward question. Okay, very good. So these are the specifications of weld which they can ask. Last question. The throat thickness of a weld section of size 8 mm for fusion angle of 103 degree. For fusion angle of 103 degree. What is the answer? Tell me. Switched on. B 4.8, great. B 4.8, great. See, it is 103 degree, means it lies in the range of 101 degree to 106 degree, right? So 101 to 106 means what? See, first of all, it is 60 to 90, yes. And then we have what? 91 to 100, yes. This you remember is what? 0.7, then decrease of 0.05, then decrease of 0.05, right? So this is 0.6. So 0.6 into, this is K values, 0.6 into 8, that gives me how much? That gives me 4.8 mm. Great. Nice. Okay. So these are some kind of questions which can ask from specifications of weld. Let us go to the next thing, that is what? The strength or shear strength of weld. So talking about the shear strength of weld, how to find out the shear strength of weld? Actually, what is the shear strength of weld? It is the load required. It is the load required for weld to fail. It is the load required for weld to fail. Right? Now load is what? Load is stress into area. Yes, load is stress into area. So this I can say is that it is the shear strength of weld that I write on what? Design shear stress. This is what? Design shear stress of weld. Design shear stress of weld. Okay, into what? Into area of weld. Into area of weld. Design shear stress of weld into area of weld. Very simple as that. Design shear stress of weld into area of weld. Yes. Now how to find out design shear stress of weld? The design shear stress of weld is the ultimate strength divided by root 3 into gamma mw. Now the weld material is also steel now. The weld material is also steel, right? So steel means what? There will be two stresses, right? We know that, right? If you draw the stress versus strain graph, you will get something like this, right? You will get something like this. First a straight line and then what? Something like this. Yes. This is the curve, right? So this is what? This is the ultimate stress in the steel and this is the yield stress. So when we are finding this shear, design shear stress, we take the ultimate one. Ultimate divided by root 3 into gamma mw. This is what? This is the partial factor of safety or factor of safety for your weld. Yes. And then this value is how much? This can take two values, right? It can take two values. If you are doing the welding in the field, then we'll take this as 1.5, right? And if you are doing it in the shop, means workshop, okay, or in a factory, take 1.25. So you can see that this is very simple. Stress, very simple. You can remember Fu, then you have two factors, root 3 for shear strength and then gamma mw because you have to use the factor of safety. Now area of weld I just told, right, it is Lw into throat thickness. So easily you are able to remember the shear strength of weld, right? So if I see from code that what code speaks about it, the code will speak the same thing. The code will speak the same thing. You see what code speaks? Code speaks that the design strength of the weld. What is written? The design strength of weld. But here it is writing in the terms of stress. This is writing what? Stress. You see stress. FYD. It is the stress. This design shear stress is how much? It is FWN by gamma mw. And what they are writing about this FWN is the nominal shear stress. Writing Fu by root 3. So indirectly they have written the same thing, right? Indirectly they have written the same thing. This is what? The design shear stress. The design shear stress. Okay? Stress. Now in this stress, when you multiply the area, in the stress, when you multiply the area, you will get the load, right? You get the load or force, because force is what? Stress into area, right? Using this, we can solve questions which they ask a lot in the examination. They ask a lot in the examination, something like this. You see, here the welding is done. Okay, the welding is done on three sides. Okay, the welding is done on three sides. Like this, the welding is done. Yes, the welding is done on three sides. And then this particular plate is having a width of 150 mm, right? And this is the overlap, right? This is the overlap. This is the overlap, right? This is the overlap, okay, of the two plates. Now they are asking you the total overlap length, okay? Total overlap length. What is written? The overlap length, if the plate is subjected to a factored axial load of how much? 310 kilonewton. So this is the force. This is the force applied. Now when this is the force applied, ladies and gentlemen, this is the force applied. That means the weld has to withstand this force, right? The weld has to withstand this force. That means the strength of the weld should be equal to this much, right? Indirectly, whenever they give a factored force like this, a factored axial load like this, you can say that indirectly I can say the strength of the weld, should be greater than equal to the factored load, right? Should be greater than equal to the factored load. Then what will happen? Then this will be safe. Or I can say at least equal to the factored load, right? And we know how to find out the strength of weld. It is Fu by root 3 gamma mw. This is what? The stress. And what is the area? Area is Lw into throat thickness. Now this is equal to 310 kilonewton. In Newton I can say multiplied under per 3. This is the equation, right? This is the equation, right? This is the equation. Now in this we have to see different terms. See, whenever they write Fe410 steel, what does that mean? This means this particular steel has Fu of 410, okay, and Fy of 250 Newton per mm square. This you have to remember, that whenever they write Fe 410 steel, that means what? That means it has a Fu of 410 and Fy of 250, right? Now nothing is mentioned. When nothing is mentioned, by default you will take what? by default you will take gamma MW as 1.25, the workshop. This is the by default you will take. If they are mentioned field, then take field. Otherwise, you will take by default what? 1.25. Okay. Now, nothing is mentioned. That means what? You will take the throat thickness as how much? When nothing is mentioned, you will take the throat thickness as 0.7s. Fusion angle is mentioned, then we can find out. Not mentioned, what you will do? So this is how much? 0.7 into 8. This is the size of the weld given. So 5.67. So ladies and gentlemen, everything is given. You see, in this particular question, everything is given or indirectly given. Throat thickness is given 5.6 mm, right? Then your FU is given 410 mm. Okay. Gamma MW will take how much? 1.25. So by taking all of this, can you give me the LW? Can you give me the LW? Tell me the LW. How much LW you are getting? How much LW you are getting? Tell me. How much LW you are getting by taking this? How much LW you are getting? Ladies and gentlemen, 292.3 you are getting, right? You are getting 292.3. Yes, but this LW is what? You can see this LW is what? This LW is, I can say, 150 plus 2 times of overlap, right? So if this X is the overlap, so 150 plus 2 times of overlap. So from here you can easily find out what? The X or overlap. That is coming how much? Approximately 71 m. Okay. So what type of questions they can ask in your strength of strength of weld? I will tell you. What kind of questions they can ask in the strength of weld? Okay, remember this. The first type of question they can ask is only they can ask you the design shear stress. In the examination they can only ask you what? Design shear stress. Okay, they can only ask you design shear stress. Suppose I am telling you if it is Fe410 steel, can you give me the design shear stress in Newton per mm square? Can you give me the design shear stress in Newton per mm square? Can you give me the design shear stress in Newton per mm square? Tell me. What is the answer to this? Yeah, very good, very good, very good, very good. Directly it is Fu by root 3 gamma MW. So ladies and gentlemen, okay, ladies and gentlemen, be careful that they will ask you small things also. Yes, small things also. Okay, I will just request once all the students to tell that, is there any background noise coming? Are you hearing any background noise of AC? Duck, 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 duck? Are you hearing that sound or you are not hearing that sound? Yes, it is coming. I'll switch off the AC then. Now it is fine, I think. Now it is fine, na? I think now it is fine, na? Okay, now also it is. Like some helicopter. Little bit. Okay. Helicopter is helicopter sound. Fine. Okay. Now okay. But again increased. Okay, I'll switch it off. Santi. Okay. Okay. So the answer is how much? 189.4. 189.4 Newton per mm square. Right? 189.4 Newton per mm square. Nice. Okay. Now in the same question, if they ask you design shear stress, same question they ask you design shear stress, okay, Fe410 only, But suppose it is mentioned it is done in field. Welding done in field. What is the answer? Welding done in field. Welding is done in field. Then what is the answer to this? Yeah, it will change, na? Yes, it will change. It will change. Yes, it will change. Yes, it will change. Yes, it will change. Now this will be what? 410 divided by root 3 divided by what? 1.5. Here it was 1.25. Default value is 1.25. Nothing was mentioned, but here it will be 157.8. You see, such type of small questions also they can ask in the examination. Okay. Or else, if they ask you the load, this was stress, na? If they ask you the load, you have to multiply what? You have to multiply simply what? You have to multiply simply the LW into throat thickness. LW into throat thickness. That's it, right? Yes. Okay. Now let us go to the next thing, that is eccentric welding subjected to shear and bending. Okay. Now I will tell you some things. Now today we will have the marathon session. Okay. Okay. At the end of marathon session. Okay. At the end of marathon session, I have taken many other sessions on steel structures. Okay. I will give you the link. Okay. I will give you the link of all the remaining lectures. Okay. Around 3 to 4 lectures I have taken, important lectures on steel structures. So after the marathon, you can have your lunch. We will have this 4-hour session now. After that, you can have your lunch. After lunch, what you will do? You will sit with those sessions and practice all the questions. Yes, you will sit with the sessions and practice all the questions. Okay. No, link I will give in the comment section. Don't worry. Link I will give at the end of the session. I will give in the comment section, and then that link you go, and then in that, MBS Baba, you provide PDF. MBS, you're an old student. I sometimes feel all of you are so inattentive in the class. Okay. Yesterday also, Abhinav sir was telling that PDF is available in the what we call that, Telegram group. So if sir is telling it is available in the Telegram group, okay, and you know that there is a Telegram group also, so why you are not joining the Telegram group? In the Telegram group you are getting the PDF, right? You are all old students now, you should know now that it is available in the PDF in the Telegram group. If you don't know, then teachers are continuously telling, okay. So teachers are continuously telling that the PDF is available in the Telegram group, and always you come to the session and you are like that PDF. At the I will tell you again I will tell. Again you will forget, or you will pata nahi kya, what happens with you. Arey Baba, there is a Telegram group of official Telegram group of BYJU'S. Once what you do now, when in the description, once you go to the description, you never go to the description. In the description there are many things. There is link to the smart playlist. Okay, I will spoon feed you now, because you all are kids. You are supposed to be now all 20 plus, 20, 21, 22, but still you are behaving like kids. Okay, you are kids only. Okay. So smart playlist is there. So in smart playlist you will get all the lectures, anyhow link is there. In the description you also find out the link to scholarship test, which never you register for the scholarship test, and then you tell that, Arey sir, I want to see full lectures but I am not able to. Then give the scholarship test na. So scholarship test link is there in the description. Then there is link for the civil engineering Telegram group is there. Okay, official Telegram group of BYJU'S exam prep. Okay, for BYJU'S exam prep there is an official Telegram group. Okay, no problem. I will tell you today. Now never forget. Okay. this you can join. Okay, in the description is there. Now don't tell me, sir, please show me in the description, sir, please click the button, sir, please come to my home and click the button, sir, please open my eyes and make me teach. So much of spoon feeding is not. Okay, you can go and join. Okay, so when you join in that group, all PDFs are available. All PDFs are available. Also, the PDFs will be also available in this smart playlist. Okay, there is a smart playlist. Okay, PDF available also in the smart playlist. Understood? Understood everyone? Now you know where to get PDF, ladies and gentlemen. Now everybody know where to get the PDF, or is there still any doubt? Okay, is there any doubt now where to get the PDF? Okay, now no doubt, huh? Very good. So now you will get all the PDF where? Okay, now some students will go to the Telegram group. Sir, in Telegram group I am unable to find the PDF. Okay, in Telegram group go to files, files. Okay, in Telegram group go to files. Okay, there is a file section. When you go to Telegram group, there is a file section. They will get all the PDFs, or in the smart playlist also you will get the PDF. Okay, okay, understood? So always have a look in the description. Okay, very good, very nice. Okay, okay, nice. So let us continue session. Okay, very good. So what I was telling, that eccentric welded connection subjected to what? Shear and bending. So you see, this is suppose a I section. Okay, and suppose we have a plate welded to this like this. Suppose we have a plate welded to this like this. Yes, plate welded to this like this. And suppose there is a load acting, and welding is done suppose over here. The welding is done, I will draw in a red color. Okay, weld is not red color, just to show that welding is done. Okay, yes, and suppose a load is applied like this, P load. So you can see that from the weld you can say plane, it is at eccentricity of P, E. So what happens? There is a bending moment P into E. When you transfer the load, whenever you transfer the load, what happens? Then we have to create a moment also, right? So there is a bending moment. So I can say there are two things acting. One is the force P, right? One is the force P, and second one is what? Second one is the moment P into E, right? Now see, this P is acting in the plane of the weld. So this force P generates what? It generates direct shear. It generates what? Direct shear. And the moment generate what? A bending moment generate what? Bending stress. This bending stress is normal stress, right? Yes. This generate direct shear stress. Okay, Q. And bending stress is what? It is normal stress, na? Bending stress is normal stress, na? And the normal stress is how much? The normal stress is equal to FB. So therefore, this is case of what? This is case of eccentric welding subjected to what? Shear Q and bending FB. Yes. Now how to find this we will understand, and we will solve a question. Now very simple. Okay. So if you see this particular diagram, it will look like this. You see, from side it will look like this, right? From side it will look like this. Suppose you have welded like this. From side, this is the I section and this is the plate, right? This is the plate, or it might be another I section also. Okay, so it will look like this, right? This is the P force, this is the E. So when you transfer the load, what will happen? The P force will act like this, which will act as what? The shear force, relatively direct shear, and there is a bending moment of how much? P into E. Very nice, right? Now this will look like this. If I am seeing from this side, if I am seeing from this side, it will look like this, right? The two sides it is welded, right? So this is welded. So this is what? The depth of the weld. This I will call the depth of the weld. Yes. And this will be how much? This will be the throat thickness, right? This will be the throat thickness, right? This also will be the throat thickness, right? Very nice. Now this particular welding which we have done, right? Yes. which is having a depth of dw, and this is throat thickness tt. This is also throat thickness tt. Now you see that for both the weld, the axis is same, na? For both the weld, the axis is same. So when for both the weld, the axis is same, what will happen? What will happen? Tell me what will happen. I can combine them to form one weld section. So this, ladies and gentlemen, becomes the weld section. So weld section is having width of how much? Width of 2 times of throat thickness and depth of equal to the depth of the weld. Very nice. It becomes a rectangular weld section, right? So this is a rectangular weld section. Okay, rectangular weld section. No need to remember many things. Very simple strength of material. Very simple strength of material. Now what happens here? You see, this width is 2 times of throat thickness. Very nice. And this depth is how much? Depth is equal to your depth of the weld. That will be given in the question, right? Yes. Now what happens here? I told that this weld is subjected to 2 things, right? P and second one is what? Second one is your P into E, the moment. I told this, due to this there will be shear stress Q. Now shear stress is what? It is load by area, na? So load by simply area of weld. That is how much? Load by area of weld. B into D, na? B into D. Yes, easy. Yes, rectangular area. So B into D. Now, due to this bending moment, there will be what? There will be bending stress. And what is the maximum value of bending stress? We have studied in center of material. That is M by Z. Now M is how much? M is P into E. Now Z is what? Z is a section modulus, right? And section modulus is what? It is I by Y max, na? A rectangular section, I is BD cube by 12 and Y max is how much? D by 2, giving me how much? Giving me how much? BD square by 6. Game over. So easily we can find out the normal stress. Easily we can find the shear stress. Yeah, this is the direct shear stress and this is the bending stress. Okay. See, basically it is strength of material, right? Yes. Once you have drawn the weld section, it is strength of material, right? Yes. Therefore strength of material was covered yesterday first. Yes. This is weld area, then strength of material. Very simple, right? So now what will happen? Now what will happen? Now we will go for the equivalent shear stress. Now what code tells about the equivalent stress test? Obviously it will depend on the direct shear stress Q and FP. So the code tells that the equivalent shear stress, you can see, code tells that the equivalent shear stress FE is how much? It is your FA, normal stress. I am FA or I am writing FB, bending stress, right? FB square plus what? Plus 3 times of the direct shear stress, square root. This is also written as what? QE, or sometimes written as what? QR, the resultant or equivalent shear stress. The resultant or equivalent shear stress, right? And obviously this equivalent shear stress should be less than equal to what? The design shear stress for safety, na? Yes, it should be less than equal to what? The design shear stress for safety. And therefore what is happening? If you see, it is less than, it is written what? Less than equal to FU by root 3 gamma MW. What is this, person? This is the design shear stress, right? So whatever is the equivalent shear stress, whatever is the equivalent shear stress, okay, that is what? That is should be less than equal to this. Let us solve one question. Let us solve question, okay? Now question time. Now question time, right? Question time. Okay. So, that is the question. Yeah, we have a MSQ question. We have a MSQ question. You see, the size of weld is given. This is S, huh? You see, the load is given P. Then the eccentricity is given E. And this is the depth of weld, right? Okay. Now, few questions are asked. You see, normal stress is 61.7. Equivalent shear stress is 28.6. Equivalent shear stress is 79. Normal stress is 28.6. Okay. So it's an MSQ question. I request you to solve this question. Okay. So I'll give you some time. Please solve this question. Chalo, solve this question. See, size of the weld is given. That means what? S is equal to 10 mm. So what will be the throat thickness? The throat thickness will be 7 mm. By default, right? That nothing is mentioned, so throat thickness will be 0.7 into S. That is how much? 0.7 into 10. That is equal to 7 mm. That is okay. Now we have to draw the weld section. The weld section, weld area. What will be the B and D? The B will be equal to 2 times the throat thickness, right? That is how much? I can say 14 mm, right? And the depth will be the depth of the weld. That is how much? 500 mm. So I know the B and D. If I know the B and D, I can easily solve the question, right? Because P and E are also known. So please solve and tell me that which options are correct. MSQ, a typical MSQ question, okay? I thought that we'll be solving some MSQ also. Yes, answer. You need to just draw the section correctly, right? Just draw the section correctly. You draw the section correctly, half paper question is done. Half paper question is done. C and D, so easy question. So you are easily able to solve this kind of questions, right? It will be easily. So MSQ, don't worry about MSQ. Yes? Tell me now, ladies and gentlemen, tell me. If you know the concepts nicely, is there any special worry for MSQs? Should you prepare something separate for MSQs, or whatever you are doing the studies, that is sufficient? If you have done the studies nicely, then there is no requirement of any separate study for MSQs. There is no requirement of any separate studies for MSQ. From the same concepts only, they will form a different option. So don't worry about MSQ. Focus on what? Understanding the concepts. If you understand the concepts, MSQs are also easy. So you see what happens. Weld section, first draw the weld section rightly, okay? Then simple, what will be the shear stress? The shear stress will be load, which is by the way how much? 250 now. 250 and this is 180. 250 kilonewton, so convert into Newton divided by area of the weld. The weld is here only, so 14 into 500. By simple concepts you can solve this question. So this Q, how much you are getting? This Q, how much you are getting? Tell me. Q, how much you are getting, everyone? Q, how much you are getting? (28.57). 28.57 Newton per mm square. Now bending stress, what I told? The bending stress is P into E by Z, that is BD square by 6, right? Very simple. 6 into P, 250, convert into Newton. Always convert everything to Newton and mm. E is 180 by BD square. 14 into D square is 500 square. So how much are you getting this value, FB value? Sorry. 200, huh? Okay, sorry, 200. 200. Tell me the answer to this. So getting 61.7 Newton per mm square. Great. Very good. 61.7 Newton per mm square. Very good. Great. Good students. Yes. So I can easily find out the equivalent shear. So the equivalent shear stress will be how much? Root under Q square. 3 is Q square. So FB square plus 3Q square. How much are you getting this value? Root under 61.7 square plus 3 into 28.6 squares, or 6 square of 57, same thing. So how much are you getting this equivalent shear stress? Sev 79.1 Newton per mm square. Very nice. Let us go to the options now. Okay, let us go to the options now. So normal stress is 61.7. That is correct, na? Normal stress is 61.7. It is correct. Yes, equivalent is not this. Equivalent is, this is also correct. Normal stress is not 28.6. Shear stress is 28.6. So answer is what? Answer is A and C. Answer is what? A and C. Try to understand, ladies and gentlemen. The small q is the shear stress. See, this is shear stress. Bending stress is normal stress, na? Huh? Bending stress is the normal stress. Understood? Okay. So the ask question you can easily answer. Now answer this question. This question you solve yourself. Okay, where is the question, man? Huh? Answer this question. Okay. It's a NAT type question. Okay. NAT. NAT. Okay. Writing round to 1 decimal. NAT question. Chalo, solve this question. Try, you try first yourself. I'll give you some time and then I will solve. Huh? First you try yourself. Let us switch on the helicopter. First you try, huh? Take your time and try. Helicopter is not landing. Hey bhai, land ho ja bhai. Ha, landed. Okay, let us solve this. Now ladies and gentlemen, okay, what is written? The equivalent shear stress is equal to the what? The design shear stress. Design shear stress we know already. This will be coming around 189.3, na? 189.4. Now what I can say? I can say that in place of your FB square, I can write down 16Q square, na? See, FB square will be 16Q square, na? So this will be what? Can I say root under 19Q square? Root under 19Q square, right? Root under 19Q square, and I can say what will be Q? Q will be this divided by what? Root under 19. Yes. So how much is this Q you are getting? 189.4 divided by square root of 19. I am getting a value of 43.45. Now FB is what? 4 times of this. Such a simple question, right? So 4 times of this is 43.45. I am getting how much? 173.8. Round to 1 decimal, almost I am getting 173.8 Newton per mm square. You see here, you need to know 2 things. First you need to know what? That what is the design shear stress. If you don't know this, you cannot solve this question, right? You should know the equation for what? the equivalent shear stress. If you don't know that, you can't solve this question. But if you know both, you can solve this question within 2 minutes. If this question is asked in the examination, it will be 2 minutes, right? Now, one last thing I want to solve from this eccentric welded connection, the previous question only, here you see, here they have asked you to find out equivalent shear stress. Instead of, they can ask you what? Find maximum load. Find maximum load which can be applied. Maximum load P which can be applied. So when they ask questions like this, how to solve? I will tell you. This is reference to the previous question. Okay. How to solve this? Very easy. See, maximum load will be for which condition? When the equivalent shear stress is equal to what? The design shear stress, right? Because if you apply more load, then what will happen? Then it will cross the design shear stress and the weld will fail. So maximum load will be for this condition. Now, what is the shear stress in terms of P? That is P by area, na? P by area. Yes. Suppose P is in kilonewton. If I want to find out the stress in Newton, what I will do? This is P kilonewton, I'll convert into Newton, divided by area. What was the area of that weld? 14 into 500, right? In the previous question, if you remember, the weld area was this one, na? 14 into 500, right? So how much Q you are getting? Tell me how much Q you are getting. How much Q you are getting? Tell me this answer. In terms of P you will tell me, right? In terms of P you will tell me. In terms of P you will get how much? In terms of P, how much you are getting? .413 na? 0.413 P na? Almost 0.413 P, right? Now, next is what? FB. FB is what? FB was PE by BD square by 6. So, what I can write down, this is 6 into P is P, I'll convert into Newton. P is in kilonewton, convert to Newton. Then E is fixed, that is 180, divided by what? BD square. So, can you find out the FB in terms of P? Can you find out the FB in terms of P? Tell me how much is FB in terms of P. Find out that. I'm getting 0.308 something. You tell me your answer. How much you are getting in terms of P? 0.309. Yes, 0.309 P. Now the equivalent stress is what? It is FB square plus 3Q square. And this should be square root, should be equal to how much? It will be equal to the design shear stress, that is how much? That is 189.4, right? Yes. So now you see both Q and FB has P. So Q square, FB square will give me P square. Square root of P square will be P. So I'll take that outside. P root under FB square 0.309 square plus 3 into Q square 0.143 square. This is equal to how much? 189.4. Can you give me the P from this? Can you solve and give me the P from this? I'll also solve. How much are you getting? I'm getting a little large value. I'm getting 478.26, correct. So we're getting 478.26 kilonewton. Okay, we're getting this value. So from this eccentric connection, they can ask you two types of question. What are the two types of question they can ask you from this eccentric connection? First thing they can ask you is what? They will give you the load. And they ask you the equivalent shear stress like this. Then what you will do? You will find out the direct shear stress. You will find out the bending stress, and you can find out the equivalent shear stress. This is the first type of question they will ask in the examination, right? The second type of question they will ask in the examination is what? That they will ask you the maximum load which can be applied, like this. Okay, so what you do in that case? The area of weld will be fixed. So what you will do? You'll find out the direct stress in terms of P like this, right? And then you will find out the bending stress in terms of P like this. Then you will find out the equivalent stress in terms of P like this, and that you will equate to what? The design shear stress. By this you can find out what? P. Just remember one thing, the P you will take in kilonewton. So while finding the stresses, don't forget to multiply 10 to the power 3. There are two types of questions they will ask in the examination from this eccentric welded connection. Hope everything is clear to you, right? And some kind of, see this kind of, one question I solved for you. See this kind of, you can say this type of questions they can ask what? I can say miscellaneous and aptitude type questions also they can ask from the same equations. Okay, so now time is 11:06. Okay, so we'll take a break now. Okay, break is required. Okay, so break is required. So we'll take a break now. Okay, so break time. So break time, and the class will resume at 11:15. So ladies and gentlemen, now it is break time. The class will resume at 11:15 am. Okay, and after the break we will study what? The bolted connection. So have some snacks, wash your face. I'll switch on the helicopter by that time. So we'll meet at 11:15 after 8 minutes. Okay, so welcome back. So it was our break. Hope you enjoyed the break. So obviously we are carrying on our marathon session. So breaks are very much required. Yes. Okay. General overview of topics. That is what we are covering. Attend the whole lecture, you'll understand. Okay. Chalo. So everybody understood? Okay. So that was welded connections. Let us see something on bolted connection now. Okay. Let us. So everybody had a break. Yes. Everyone had some food, some juice. Yes. So I'll be giving another break also. Don't worry. We will have breaks. Otherwise, our mind will not work. Na? Yes. Breaks are always required. So we'll have breaks in between always. Okay. Chalo then. We'll start. We'll start in 1 minute. The prince had juice. Very good. Okay. So break is over now. So we'll remove this. Time for bolted connections. Time for bolted connections. Okay. In bolted connection, ladies and gentlemen, these are the important topics. Specification of bolted connections, shear strength of weld, bolt, okay, and then the bearing strength and the tensile strength. There are three types of strength of a bolt. Okay, one is the shear strength they will ask you. Yes, one is the bearing strength they will ask you. One is the tensile strength you will ask you. And this is what specifications they will ask first. A lot of questions are asked from specifications. Then there is eccentric bolted connection, torsion, and then there is eccentric bolted connection, shear and tension. Shear and tension. Okay. Chalo, then we'll start the session. We'll start with specifications of bolted connection. So in specifications of bolted connection, the first thing is minimum pitch. Now when you are discussing minimum pitch, first to understand what is a pitch, right? So what is the pitch? If you have bolted connection connecting two plates, okay, and force is applied in this direction. Force is applied in this direction, then the center to center distance, in the direction of force is known as what? This is known as pitch. Now when we are talking about minimum spacing, the minimum pitch, what the code tells? The code tells that, you can see this is tightly from code I have taken. It is 2.5 times of the nominal diameter of the fastener, or I can say bolt. So I can say that the minimum pitch is how much? It is equal to 2.5 times of the nominal diameter of the bolt. You see this small d is what? This is the nominal diameter. This is the nominal diameter of a bolt. Now let us see some general specifications of a particular bolt. Let us see some general specifications of a particular bolt. So if you have a bolt, okay, if you have a bolt, now bolt will go inside a hole, right, in the plate. So if this is the bolt, yes, and suppose this is the bolt I am setting completely, and this bolt has a diameter of small d. Okay, a diameter of small d. So this small d is known as what? This small d is known as the nominal diameter. It is known as what? The nominal diameter. Now obviously the whole diameter will be bigger than that. That is known as what? D naught. It is what? The whole diameter. Obviously the whole diameter will be bigger than the nominal diameter. Okay. So I can say that this whole diameter is nominal diameter plus some clearance, right? Some clearance. Now that clearance is how much? That clearance is three things are there. This clearance is 1 mm, it can be 2 mm, it can be 3 mm. So it is 2 mm for nominal diameters ranging from 16 to your 24. It is plus 2, yes. If it is greater than 24, then plus 3. If it is less than 16, then plus 1. Okay. This is general specification you might be knowing, just I revised. Nice, very good. So minimum pitch is how much? Remember, it depends not on the whole diameter. It depends on what? It depends on the nominal diameter. Depending on what? It's depending on the nominal diameter. Important. Next thing, the maximum pitch. This was minimum pitch, then the maximum pitch. What code tells about the maximum pitch? Now, the minimum pitch was independent of it's a tension member or compression member. But maximum pitch, it depends upon it's a tension member or compression member. What is written? It is written the distance between center to center between the two adjacent fasteners, or I can say the bolts, that is on the pitch, should not exceed. Shall not exceed means what? Less than equal to, right? Or I can say the maximum value, right? Is equal to 16T or 200 mm, whichever is less. Means what? Minimum. Yeah, this is for what? This is for tension member. This is for what? Tension members. If you are applying tension to the connection, then what? Then I can say this is the rule for maximum pitch. Now, the same maximum pitch become how much? 12T or 200 mm, whichever is less, or I can say minimum, if it is a compression member. If it is a compression member. Okay, so these are what? The clauses for what? Your minimum pitch or maximum pitch. Rightly they can ask questions. We'll solve also, don't worry. Now next thing is what? The next thing is your minimum end or edge distance. Now first of all, what is this end distance? What is this edge distance? So if we have load applied like this, okay, this distance at the end in the direction of force, this is known as end distance. Is known as what? End distance. Now perpendicular to the force, this is your edge distance. Or I can say, you can see it is edge, and it's very understandable, but still it is what? I can say definition wise what? It is perpendicular to direction of force, right? You can see the edge distance is what? It is perpendicular to direction of force. It is perpendicular to direction of force, right? Whereas this end distance is what? It is parallel to direction of force. Now these small things they can also ask as objective, therefore we are discussing direction of force. Now what code tells about this? That what will be the minimum end or edge distance? The code tells that, what the code tells? The code tells that the minimum end or edge distance, the same clause is applicable, is how much? It is 1.7 times the whole diameter, not the, see in minimum pitch it was bolt diameter or nominal diameter. It is whole diameter if it is what? Sheared or hand flame cut. And it is 1.5 D naught when it is rolled or machine flame cut. Now by default we can take this one, machine flame cut. By default we can take what? Either it is machine flame cut or it is rolled. Normally we find this one. So by default we can take this one. If they don't mention anything, yes. If they mention hand flame, then obviously you have to take 1.7. But if they don't mention it, okay. If we are not mentioned it, then what we will tell? Then we have to go for this 1.5 D naught. This is the minimum end or edge distance. Now coming to the maximum end or edge distance, that is how much? What the code tells? The code tells the maximum end this edge distance is how much? 12T into epsilon, where T is the thinner plate, okay, thinner member I can say. And what is this epsilon? This epsilon is simply 250 by Fy. It is 250 Fy to the power half, that means what? 250 root Fy. For example, if I am telling that Fy is, normally it is Fy is 250. Normally what happens? Fy is 250 only. If you are using Fe410, normally this is the Fy. And normally I get epsilon how much? Normally I get epsilon 1 only. So if I say that we are connecting two plates, suppose 12 mm we are connecting with 16 mm through bolts, two plates are connected. So I can say this maximum edge distance or end distance will be how much? Simply 12 into 12, that is how much? 144 mm, right? 144 mm. Understood? Very straightforward, right? Yes. Let us solve some questions now. Minimum pitch we saw, maximum pitch we saw, minimum end distance, maximum distance. Let us solve some questions now on the specifications. Now answer this question. Answer this question. Answer is yeah. You see, whenever they write this M20 indirectly means what? This is the nominal diameter or bolt diameter. This is given as 20 mm. So what will be the the whole diameter? See, this falls in the range of 16 to 24, na? So it will be plus clearance will be 2. So 22 mm. Yes. So it is asking minimum end distance. So we'll take what? 1.5 D naught gives me how much? 1.5 into 22 giving me 33 mm. So typical 1 mark question for gate, right? Next question solve and tell me what's the answer to this. The minimum pitch when two plates 12 mm and 16 mm are connected using M20 bolts. M20, M22, M16, that means what? This is the bolt diameter or nominal diameter. Remember that, huh? Answer this. What is the answer to this? You see, minimum pitch is 2.5 times of simply D, not D naught, simply D. Straightforward question, 2.5 into 20. Giving me how much? 50 mm. Straightforward question. 50 mm. Next question. Solve this question. The maximum pitch. Read the question properly. All the 4 options I will get. I am filling. Let us see. Solve this. A, B, C, D, E, F, G. Okay. First of all, it's a tension member. It's a tension member. That means what? The maximum pitch will be minimum of 2 things. What? 16T and 200. Right? Now this T will be the thinner one. This T will be the thinner one. Thinner means how much? 12. Always it will be thinner one. So 16 into 12, 192 and 200. Which one is minimum? Answer is 192. Right. Okay. Very good then. Let us go to the next thing, that is the shear strength of bolt. Let us go to the next, that is what? Shear strength of bolt. While we are discussing this shear strength of bolt, suppose this is 2 plates and connecting in this manner. Yes. So this is a bolt, okay. So this is a lap joint. The bolt is in a lap joint. Now when there is a lap joint and we are applying load like this and load like this, there is a chance that this particular bolt might fail here in shear. Yes, at this location. At this location it might fail in shear. Yes. I'll draw in some different color, suppose blue. Okay, it's not visible either way also. White is better. It can fail here in shear, right? So this is known as what? A shear plane. This is known as what? A shear plane. And I can say that the number of shear planes in a lap joint is how much? It is simply 1. It is simply what? 1. Now if you see a typical bolt, the bolt is something like this. There is a threaded portion and there is a sank portion. Okay, there is a threaded portion and there is a sank portion like this. Okay, this is a typical bolt. This is a typical bolt I have drawn. Now, the bolt diameter is D at the sank location. At the sank location. This is the head of the bolt. This is the head of the bolt. And this I can say is the sank. This is the sank area, sank portion. Yes. And this I can say is the threaded portion. This is one I can say what? Threaded portion. Now this sank portion also I can say as the gross portion. I can say the gross portion. And this threaded one I can say is the net portion. Now if I ask you the sank area of bolt, sank area of bolt, ASB, terminologies you don't get confused. So ASB, A for area, S for sank and B for bolt obviously. So sank area of bolt, that will be simply what? Circular cross section, right? So pi by 4 d square. Nice. Now if I tell about net area of bolt, net area of bolt, or I can say the area of the threaded portion. So A for area, N for net and B for bolt. That is considered as, you can see that it is less than the sank area. Now from diagram also it is clear. That is considered as 0.78 times of the sank area. That is considered as 0.78 times of the sank area, ladies and gentlemen. Yes. Now this shear plane by default, this shear plane, this one shear plane by default will assume it is, see, it can pass through sank area also, it can pass through the net area also. But if it is not mentioned in the question, see in the question they will mention it passes through sank area or passes through net area. If they don't mention that, then what I will assume? Assume the shear plane, passes through net area. Passes through net area. This is the assumption we take. If it is not mentioned in the question that is passing through net area or sank area. If they give sank area, very good, I will take that as sank area. If they give net area, very good, but if they don't mention, then I have to do this assumption. Okay, I have to do this assumption. Okay, so this is a lap joint we saw. In lap joint we have one shear plane, it passes through the net area, nothing is mentioned. Now the next thing is a butt joint. You can see it's a butt joint. Here in butt joint, these are known as the main plates. They are known as what? The main plates. Okay, main plates. And these are known as what? The cover plates. This is known as what? The cover plates. The main plates and top and bottom cover plates. And this is known as a double cover. We call this as what? Double cover butt joint. Double cover butt joint. Now, ladies and gentlemen, if I have a bolt like this here, I'll draw only one bolt. I can draw many bolts, but let me just draw one bolt here. Okay. If I draw only one bolt, yes, I have bolted like this. This. So you can see that there are two shear planes, right? There are two shear planes. Yes. One shear plane is this, one shear plane is this. So there are two shear planes in a double cover bolt joint. And I assume that both of them pass through what? Net area if nothing is mentioned. Nothing is mentioned. Now coming back to what? The shear strength of the bolt. Now this is the load, I can say. Shear strength of bolt is what? It is the load actually. It is the load actually. So load, how we find out load? Okay. Pardon me, just have cough. There must be two bolt you are. I told that I am drawing only one bolt. I will draw two bolt. I will show you top view. I will show the threaded portion. It was just to show one bolt. Okay, let me draw so that you can become little happy, but I will not draw because I don't want to. Understand the context in what sir is telling, what sir is going on. I told that I am just showing one bolt, okay. Must be two bolt. Okay. Now coming to the strength, this is a load I can say. This is what? The strength is a load actually. Okay, load. That how much load you will apply that, this particular bolt will fail in shear. Now load is again what? Stress into area, right? So the shear strength of bolt, I will call this BDSB. This is what? Design shear strength of bolt. Design shear strength of bolt. Design shear strength of bolt. Yes. D for design, S for shear, and B for bolt. Okay. Now this is what? This will be the design shear stress. Design shear stress. Design shear stress into area of bolt. Yes. Into what? Into area of bolt. Yes. Very good. Into area of bolts. Now see, design stress will be very similar to what we studied in your weld. Remember, there we studied what? Fu by root 3 gamma mw, right? Here it will be what? In case of W, it will be B because it's a bolt, right? And here it will be FUB. FUB means what? The ultimate strength of bolt. So it's very similar to what you have studied in your weld actually. It's very similar to that. Yes. So, and here since all the bolts are prepared in the workshop, it will be always 1.25. Here there is no concept of 1.25 or 1.5. In weld we have concept of 1.25 and 1.5, but here only 1.25. Now how to find out this FUB? That comes from the grade of bolt. That comes from what? The grade of bolt. Okay. So if we have a grade of 5.6, suppose I am telling 5.6. How to find out? This you take this before decimal, this number and multiply 100. That will give me what? Suppose, no, let me take something else, like suppose I am taking 4.6 I am taking. So this I will take what? 4 multiplied by 100, giving me how much? 400. So this is what? This is your FUB. This is how you find out FUB. Now you take this remaining 0.6 and then multiply with the FUB. You will get the FYB. Easy. And I can say what? 240, right? I can say 240. Easy, right? Now suppose I tell grade 8.8, right? If I say grade 8.8. So in this case I can say you take the 8, grade 8.8. You take the 8 and multiply 100. I'll get what? 800, right? You take the 0.8, remaining 0.8 and multiply with the FUB. This you get FUB, okay? Multiply with this, suppose I am getting 640. But not suppose that we are getting 640 is FYB. The yield strength. This is yield, this is ultimate. And here we use ultimate. Okay, here we use ultimate. Now area of bolts. Area of bolts. Now area of bolts, you see if it is a lap joint. If there is a lap joint, then there will be only one area, na? If it is a lap joint, there will be only one area. And if I assume that is passing through net area, then I will say net area of bolt, right? If it is the lap joint. Now if it is a butt joint, if it is a butt joint, double cover butt joint suppose, and I tell that there are two shear areas and both are passing through net area. So I can say 2 into this for double cover butt joint, right? And if I say that it is a lap joint, but it is passing through shank area, then ASB. And if I say that it is a double cover and passing through shank area, then 2 into ASB. If I say it's a double cover and one is passing through shank area, one is passing through net area, then I'll get this one, right? Yes or no? So it can be anything, na? You see this area can be anything. It can be ASB, it can be A and B. See ASB, A and B for lap joint you will get. For double cover butt joint you will get either 2 into A and B, or you will get what? 2 into ASB, or you will get what? ASB plus A and B. That depends on the question and the assumption we take. Yes, that depends question on assumption take. So what I will do, general formula I will write down. Number of shear planes through shank area into your shank area of bolt plus number of shear planes through the net area into net area of bolt. This is the general equation I can use. This general equation I can use. And this is, ladies and gentlemen, the formula for finding the shear strength of bolt. This formula looks difficult when we directly see the code. You see, if you open the code, I am now referring to the code. You can see the code tells this. The code tells that VDSB is VNSB divided by what? Your gamma MB, and then VNSB they write FU by root 3 and then ANB NS ASB. Now when you find out VDSB, the design shear strength of bolt, you divide by gamma MB, so obviously what will happen? When you write down here, it is divided by gamma MB, na? So above equation divided by gamma MB. So FU by root 3 gamma MB, then what? Number of shear planes passing through what? See what is it? Shear planes with threads. Means threaded portion is one net area. Yes, into net area of bolt plus the remaining thing. So you see that these equations which look very clumsy and difficult in the code are actually very easy to understand if you have understood the concept behind them, right? If you have understood the concept behind them, then these equations are very easy to understand. Now code has this habit of, one thing they do. They do this thing always. They will write down this is nominal shear strength of bolt. This is what? Nominal shear strength. Okay. N. Okay. And then the design shear strength of bolt, that is the nominal shear strength of bolt divided by the factor of set, that is gamma MB. I directly refer to what? Directly refer to this design shear. Design. I go to design. This is what? Design shear strength. In one equation, khatam. Okay. Otherwise, it's become very confusing, na? Yes or no? Which one is nominal? Which one is design? In the exam, they ask you design only. In the examination, they ask you design only. Then why to go to this nominal and then divide by gamma MB? Directly, I remember what? Your design strength. So everybody is now comfortable with this formula. Understood this formula? Yes, understood this formula. Let us solve one MSQ. Let us solve one question. Chalo, MSQ question. Grade M20 bolt means what? Your D is equal to 20 mm. Grade 5.6 is given. Is used in a double cover butt joint of 2 planes. Double covered butt joint means what? 2 shear planes. Now something are given. Please find out the answer and tell me which is the right answer. MSQ. Chalo, solve it. In between, I will request all of you that this video, if you are liking it, see, you like the video, don't like your wish. Doesn't matter to me. Okay? You share the video, don't share the video, doesn't matter to me. Okay? I will tell don't share. Study yourself. Why to share the benefit to others? You study yourself. But, subscribe to the channel. There are 3 things now: like, share, subscribe. Yes, I will tell you to subscribe to the channel if you have not subscribed, because if you subscribe to the channel, you will be benefited. You can attend all the lectures which are coming up in the future. You will get a notification. You will not miss any lecture. So like and share your wish, but subscribe my recommendation. ABD, yeah. Bangalore fan, huh? RCB. Okay. ABC, ABD, confused. Okay, so now see notification came. Subscribe, otherwise you will miss videos. You will miss the videos. So subscribe to the channel. Okay, see first 2 are correct. Because you see this is grade 5.6, then what will happen? FUB will be 5 into 100. That gives me how much? 500 MPa. Yes. So FUB is correct. Remaining is 0.6. So 0.6 into FUB will give me FYB, the yield strength of bolt. That is how much? I can say 0.6 into 500. That is equal to 300. 300 Newton per mm square. Okay. So first 2 options are correct. Coming to the third option, third or C or D, the shear strength of bolt. See, when they're asking you shear strength of bolt, first is the stress. Stress will be how much? FUB. FUB by root 3 gamma MB will be 1.25. See, this is the best way to remember the equation. First you write down the stress. Now coming to the area, stress into area. Area, there are two shear planes, right? And assume both the shear planes to pass through net area, because nothing is mentioned in the question. Nothing is mentioned in the question. So assume both are passing through what? Net area. So 2 into net area will be 0.7 times of shank area. So 0.7 times of shank area will be how much? Pi by 4, 2 into point this, what happened? Then 20 square. Okay. Now this answer you will get in Newton. So divide 10 to the power 3 to get in what? Your kilonewton. Solve this. So you're getting how much? You're getting 113.2, right? You're getting 113.2, right? Are you getting 113.2? Yes. Very good. Very good. Now this D option was correct if it was mentioned in the question. Suppose it is mentioned in the question that both shear planes pass through shank area. Yes. If it was mentioned in the question that both shear planes, if it mentioned in the question that both shear planes pass through shank area, then I can say that I will remove this 0.78, right? I'll remove this 0.78. Means what? Is this 113.2? I'll divide by 0.78. Then how much I'm getting? I'm getting 145.12. Understood? So D option was for that case. D option was for that case. Okay. Now suppose it is asked in the question. Suppose it was asked in the question that one shear plane passes through net area. If it is only one shear plane passes through net area. That means what? The other one will pass through shank area. If it is written in the question that only one shear plane passes through net area, that the other one is passing through shank area. So if this particular line is given, then give me what will be the shear strength. Tell me. Solve it. If this line was given, solve this. $129. What will happen here? You see, it will still remain. See, the stress will not change. FUB by root 3 gamma MB, that is intact. What will happen? One will pass through shank area, another one will pass through net area. Yes, and this I can write down as 0.78 times of net area, right? So can I say this will be 1.78 times of your shank area, na? Yes, because you see shank area is, net area is how much? 0.78 times of shank area, na? So take an item this. So this into what? I can say into pi by 4 into 20 square. So if you solve this, you'll be getting how much? You're getting 129.1 kilonewton. You can see that when both are passing through shank net area, I am getting 113 obviously, because net area will be less. When one is passing through shank, another one is passing through net, I am getting 129, obviously little more because shank area is more. And both are passing through shank, and I am getting 145, the highest one, because shank area is obviously greater than net area. Yes. So nice question, and this is what? This is your what we call that? Your shear strength question they can ask. Next is bearing strength of bolt. How to find out bearing strength of bolt? Okay. So bearing strength of bolt, it is also a load, right? When the bolt fails in bearing. Now what is bearing failure? We'll understand that. If this is a bolt, and the plate is connected like this, so what will happen? The plate will exert some stress. Okay. So due to this, there might be crushing here. This is bearing failure. Right? So now you see, if this is a bolt and this is the stress coming from side, right? You see, top view, right? Top view. Then I can say this is applied on this projected area, this projected area. So if I see the 3D diagram, if I draw the 3D diagram of this, so stress is coming like this from the plate, and this will be projected on this vertical area, right? This vertical area, and this area will be how much? You see, this will be diameter of the bolt, right? So this will be D, and this will be thickness of the plate. Yes, the thickness of the plate where the stress is applied. So I can say this area of this particular stress is D into T. So now when I'm finding the bearing strength of bolt, what is the formula? This is BDPB. The formula is area. Area is how much? D into T only. Area is D into T. Easy. Area is D into T. Now what is the stress we take? The stress we take is Fu, and this we take for the plate because the plate is applying the stress. So we take here plate, not the bolt. FUB we take for shear strength. For bearing we take Fu. So this is the load. Very easy. With this we apply some factors. One factor we apply is 2.5. Another factor we apply is gamma MB. Okay, gamma MB divided by gamma MB. Another factor we apply is KB. Actually, you see, this 2.5 by 1.25 will give me 2 actually, right? Actually, it is 2 into KB, na? Yes. Just it is written like this. So what is KB? KB factor is minimum of 4 things. Minimum of 4 things. One is E by 3 D naught. Next is P by 3 D naught minus 0.25. Next is your FUB by FU and 1. So I can say that this KB is the minimum of this 4. Where E is the end distance, D naught is the whole diameter, P is what? The pitch, FUB is for the bolt, FU is for the plate. Remember this, plate. So now this equation is easy to remember. Let us see what code tells about this. The codes obviously will be writing in a complicated language, so we'll simplify that. The code speaks that, you see, what is writing? They do the same nonsense that, no, not nonsense, sorry, means the confused people, okay, but I will try to not confuse you. So see, D into T is the area, Fu is what? The stress. Yes, and this is for the, you see, Fu is for what? It is for the plate. Fu is for the plate. So stress into area. Then we have 2.5 and KB is the nominal one. Finding the design one, what we do? We divide by gamma MB. Yes. And KB is what? Minimum of E by 3 D naught, P by 3 D naught in minus 0.25, FUB by FU and 1. Solve one question. MSQ. Chalo. So let us solve this question. An M20 bolt. M20 bolt. M20 means D is given as 20. Grade is given. We know how to, from grade we find out things we know. Right? Now, it's a lap joint of 2 plates, each having thickness of this 16 mm. So this is the T. Then this is your FU. Because for plate is this. FUB is how much? FUB is 400. FUB is 400 Newton per mm square. And FU for the plate is your 410 Newton per mm square. See, FUB and FU will be different. FU is for the plate, FUB is for the bolt. Pitch is given and distance is given. Okay. So find out the answer. Let us see who solves first. Solve this question. CD. Very fast, you see. See, if you know the formula, such questions in the examination you can solve in 1 minute, right? I always tell these lines. Many people agree or don't agree. Gate, there will never be, you can say, shortage of time. If you know the concept, you know the right formula, you will be able to solve the question, and you can revise also in gate. In gate, you can revise also. You need to know the right formula, right method. That's it. Now see, we write down the find out KB. KB is how much? E by 3 D naught. D naught is how much? D naught will be 22 na here. Yes. D naught will be 22 na. Yes. D naught will be 22. So I can say by 2 D naught. Then P by 3 D naught minus 0.25. Then FUB by FU. 400 by 410. And last is 1. So what you are getting? This one, so you are getting 0.5 with the calculation also. This one you are getting 0.66 na? This you are getting 0.66. See, this will be close to some 0.9. Need not to find also, right? Need not find also. 0.9798. Obviously, it's looking close to 0.9798. Not required to find out. And this is 1, so obviously this is the KB. So KB we got. Next is bearing strength. Bearing strength is very easy. 2.5. KB is 0.5. First write down all the factors. Gamma MB is. So you can also remember this as 2 into KB actually, right? 2 into KB. 1. All the factors is 1. Then D into T, the area, position area, it is how much? 20 into 3, 16. And then F for U. Then what? F for U. Not FB. F for U. Means not FUB, only FU. Now divide into power 3 to convert into kilonewton. Getting how much? 131.2. 131.2. Understood this question? Now same question I want you to find out the shear strength of bolt. Find out the shear strength of bolt also. Find out the shear strength of bolt. They can ask you another MSQ also, na? In the same thing they can mention find out the shear strength of bolt also. Find out shear strength of bolt for this question. Find out. It's a lap joint. Find out the shear strength of bolt. Find out shear strength of bolt. Sixty 60.6. Others. If you want to find out shear strength, the word is what? Fu by what? Fu by root 3 gamma MB, okay, into net area of board. There is only one shear plane. Now it's lap joint. It is lap joint, right? It is lap joint. If it is lap joint, only one, and that will pass through net area by default. Okay, that is I can say here FUB. That means I'll use 400. Understood? So 400 by root 3. Gamma MB is 1.25. Net area of bolt will be 0.78 into pi by 4 into 20 square. Now divide by 100 per 3 to convert into kilonewton. So how much are getting this value? Getting how much? 45.27 kilonewton. Understood everyone this question? And everyone? Yes. Okay. Not asked, I have just extended it. Now suppose I am asking you find out the bolt value. If they ask you the bolt value or strength of bolt, the bolt value or strength of bolt is always the minimum of the shear strength of bolt and the bearing strength of bolt. And that is how much? Here the bolt value is 45.27 because the shear strength is minimum here. So in the examination they can ask you bearing strength of bolt. Very good, you can find out. They can ask you the shear strength of bolt. Very good, you can find out. They can ask you the bolt value. If they ask you bolt value, you have to find out in this manner. Take the minimum of this. Bolt value, or I can say only strength of bolt. Only strength of bolt. Now if they ask you number of bolts, suppose they ask you number of bolts. Suppose they ask you how many number of bolts you will use. Or minimum number of bolts. That will be how much? the factored load which is coming, right? The factored load divided by what? By the volt value, right? Divided by what? By the volt value. Suppose I am telling that a factored load of 300 kilonewton is applied. Suppose I am telling a factored load of 300 kilonewton is applied. Then what number of bolts, then tell me? What number of bolts you will require, tell me? What number of bolts you will require, tell me? Just divide it, you will getting how much? 300 divided by 45.27. I am getting a value of 6.63. So obviously cannot use 6.63. I'll use what? 7. See, if it was 6.23 also, you'll use 7 volt only. Means we can say round to next integer, not nearest. Round to what? Next integer. Understood? So in this thing, they can ask you what? I explained everything, right? What all they can ask. Okay, very good. Let us go to the next thing I wanted to tell you, all of you. That is compression members. Let us study something about compression members which they can ask in the examination. In compression members, they can ask you effective length, design compressive stress, lacing and batten, and column base plate. What are these things? You see, if you have a compression members, a column, yes, a column like this, yes, column like this. Okay, compression members can be found in two. See, one is the typical columns which you get, a beam column, like steel, beam column things, right? So if you have a beam column frame structure, so this will be a beam and this will be a column. So this is what? This is a compression member. This is a compression member. Nice. Now in a truss, we know trusses. But I studied trusses. We know trusses that the truss members only take what? Axial load, right? They take only what? The axial load. So if they are taking axial load, yes, we know how to analyze the stresses by using method of section and method of joint. Now we know that some members will get compression, some members will get tension, and that is very random, right? That is very random. We can't say that which one will get compression, which one will get tension. We don't know. That after finding we can say. So suppose this is getting compression means what? If you see the cross section, it will be something like this. Axial compression coming to picture. So this is known as a what? This is also a compression member. So columns are compression members, and these truss members which are taking axial compression are also compression members. They are known as what? Struts. They are known as what? Struts. So in trusses they are known as struts. Okay. When they are used in beam column frame structure, they are known as column. Sometimes they are known as what? Stanchion also. Known as what? Stanchion also. Okay. So struts are actually compression members in trusses, right? That compression members in trusses, and columns are, I can say, the compression members in framed structure, in a framed structure, right? And both of them take what? Let that be a strut in a truss or a column in a frame structure. Both of them take what? Axial compression. Both of them take what? They both take axial compression. Nice. Okay, so what they will going to ask in the examination? First, they will ask you effective length. Then they ask you design compressive stress. Suppose we have a column. Okay, we have a column, right? So in a column, if we know that how much stress I can apply, FCD, this is what? Design compressive stress. This FCD is what? This is your design compressive stress. Design compressive stress, right? Design compressive stress. Now, if I know how much is the design compressive stress, so by multiplying the area of the column, I can find out the design load, right? This is what? Design load. But how much design load I can apply? Yes. How much load I can apply on this particular column so that it doesn't fail, right? So therefore, to find out the design compressive load, you have to find out what? The design compressive stress FCD into area. See, area will be knowing, obviously the cross section area we can find out. So how to find out this design compressive stress, that is asked, okay? and then this column is placed on some pedestals, right? We know it is placed on some concrete pedestals, right, to transfer the load sufficiently, and so that the pedestal doesn't fail in bearing, because the pedestal of bearing strength of 0.45 FCK. So we provide here what? We provide here column base plate. We provide here what? The column base plate, right? And the thickness of this column base plate, TS, the thickness of this column base plate, that is also asked in the examination. So these things are mostly asked in the examination, so we'll be exploring them one by one. Let us explore them one by one. Okay. So first one we will study is effective length. So directly we'll go to code. Now these are the effective length as per IS code 800 and also as per what? IS 456. As per both, these are the same code. Now both of them take the effective length from what? From Euler's buckling theory, right? Buckling theory. But what the code does, the code will add some, spice. It will change the thing little bit, because during buckling theory is the theoretical thing. So adding something practicality into the picture, so they will change. How they will change? You see, first of all, let us see that what is the K. See, this effective length is what? K into L. This effective length of a column or compressive member is K into L. So to know the K, rightly I have written K into L written only, so K. So you see here the K is 2. You can see that here this end is fixed, the other end is free. Okay, other end is free. So how we denote that? You see, when it is fixed, that means there will be what? If it is fixed, there will be no translation. It cannot move. There is no translation, there is no lateral movement. And there is no rotation also. It cannot rotate also, fixed now. But the other end is free, so it can translate, it can rotate. Therefore you see, what is written? Restrained. Translation is restrained and rotation is restrained. Restrained means what? Not allowed. And free means what? The other end free means what? It is allowed. It is allowed. Okay. So they might not ask you one end fixed, one end free. They might ask you in these terms. In what terms? They can ask you that restrained at both ends and free at other end. Like this language they will use. It's not knowing the language. Now you see the next one. What is written? Free for translation. Okay, free for translation. This end, you see, this end. You see, it is free for translation. See, translation is possible, na? It can move, right? It can move horizontally. Translation is possible, but rotation is restrained. You see, translation is possible, rotation is restrained. The other one, okay, some language problem is there. Other one, translation is restrained, free and restrained. How it is restrained? Okay, how it is restrained is not restrained actually. It's not done properly. We'll not discuss this. Not required actually. Okay, we'll go to this, the more important one. Ignore this, huh? I'll come to this later. Ignore this. Come to this. Here what happens? Both ends are your pinned or hinged. Pinned or hinged. When both ends are pinned or hinged, that means what? You can see here, it can rotate. So rotation. Here also it can rotate. So rotation. But it cannot move. There is no translation. Therefore what? The translation is restrained. Translation lateral movement. This is simple na. This is the end. I have told many times. I will again repeat that this is rotation. So rotation is restrained means it cannot rotate. It can only translate. Means what? It can only translate like this. It cannot rotate. Okay. But here it can rotate. So it can rotate at its own place like a hinge. Rotate at its own place, but it cannot translate. Hinge can also not translate, right? So 1, or I can say K is 1 here. K is 1 here. Now this language is why I am focusing, because in the examination they might not give you both end pinned. They will use some language. That is the problem where students get confused. Therefore I am discussing this. Now the next thing you see, we'll start from the bottom here. You see, here both ends are fixed. Both ends are fixed means what? you see translation is not allowed, rotation is not allowed, translation is not allowed, rotation is not allowed. All are restrained, you see, restrained, 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 restrained. Everything is restrained. So both end are, uh, fixed. Now in this, theoretically it is 0.5, right? Theoretically it is 0.5. Code increases it to 0.65 because complete fixity is not possible. Yes, complete fixity is not possible. Now come to the next thing. You see here it is hinged. Hinged means what? Translation is not allowed, rotation is allowed. The other one is what? Other one is fixed. So both are not allowed. You can see one and both are not allowed. Other end, what is happening? The translation is restricted, but the rotation is free. Yes. Now this special one, you see what happens? So but before that, the K value, theoretically the K is how much? 0.707, or I can say 1 by root 2, right? But as per code, it increases to 0.8. So you can see that it is increase in the K value from theory to your practical value taken for IS code, both concrete structures and steel structures. It increases. Why? Because complete fixity is not possible. Yes. So in codal things, we'll take the red one, right? Now the next thing you see, one end you can see is fixed. So I can say your translation, rotation, both are restrained. So I'll cut both them. Restrained. But you see here it can translate. Horizontal movement is there, but rotation is not allowed. You see what is happening here? Restrained, restrained. Yes. No. We use FE410 only. We use FE410. Yeah. And here what? Here it is free, na? See, translation is free, restraint. So this is what? Translation, this is rotation. This translation, rotation on both ends. Okay. So like this, they will frame questions. They will frame questions. Okay. And here we'll take how much? 1.2. Now solve this question based on the effective length. Based on effective length, they will ask you questions. So based on effective length, we'll solve a few questions and then we will take our second break. Solve this question. H per IS 800 for a column having held in position. Held in position means what? Restrained against translation. Held in position means restrained against translation. And held in direction means restraints against rotation. Now what is the right answer to this, ladies and gentlemen? This type of question, they will ask you one more question, okay, and you should be ready to solve this type of kind of question. This is common to both RCC and steel. The others, why are you not answering? Okay, take your time, take your time. Take it. See what to do, how to solve this kind of question. So whenever you get confused, draw the column. Draw the column. Whenever you get confused, draw the column, okay? Draw the column. चलो draw the column कर दिया. Okay. Draw the column. Okay. Write down translation, write down rotation. What is written? Held in position at one end. Held in position in one end means translation is not allowed at one end. That means allowed at other end. See, not allowed at one end. That means what? Allowed at other end. Yes or no? Having held in position at one end. One end means the other end is free. Other end is free. Yes. Now restrained against rotation at both end. That means what? Rotation is not allowed at both end. Now tell me what is the answer. Now tell me what is the answer. Now tell me what is the answer then. डी डी ए क्या कर रहा है, ए कर रहा है, डी है ना, यू सी you see, now tell me what is the answer, D na, convinced, convinced okay, see normally what happens, we have this habit of remembering fixed and pinned and free, like this we have remembered, yes, and therefore what happens when they ask questions like this, we get thoroughly confused. The answer is D. So let us practice. I will give you another question now. Tell me the answer. Answer to this. Draw the column, draw. Whenever you get confused, draw. Translation, rotation. Translation, rotation. Okay. Held in position at both ends. Means both end, translation is not allowed. Restrained against rotation at both ends. Both end are fixed. Answer is what? This is B, 0.65. 0.65. Yes, understood. Now let me use another language. What is the answer? See, again we will draw. If you are getting confused, draw. Draw. Translation, rotation. Held in direction at one end means what? Means at one end rotation. Direction means rotation. Restrained against rotation. That means one end only it is restrained, other one it is allowed. And held in position at both end. This is what? This is fixed, the other one is pinned, na? We'll get how much? We'll get 0.8. A option. Understood now? Now this kind of questions you can solve, okay? And therefore it is important to understand these languages. See, held in position means restrained against translation. Translation is also lateral movement. Okay, remember these words, right? Remember these words. Translation means lateral movement. Lateral movement. Same thing. And if they ask you, held in position means what? Translation is restricted. Held in direction means what? Rotation is restricted. Restricted, restrained means what? Not allowed. See, so many language combinations they can do. They can write not allowed, restricted, restrained, allowed. Yes. So you have to understand that, okay? So this type of questions you should, know. Because see, it is very less chance that they will ask you what? See, they might ask you one end is fixed, other one is free. That becomes very easy, na? Yes. But in the examination, they might ask you in this language and you should be aware of this. So that's it. So break time now. Okay. So break time, yay, break time. Okay. So have some food now or whatever you want to do. After this, I am going to teach a very important concept of compression members. So you need to be little active. So we'll meet at 12:30. Class will resume at 12:30. Okay, chalo, subscribe to the channel. Okay, so that you don't miss any notification. Chalo, we'll meet at 12:30. Bye. I'll switch on the helicopter till that time. Switch on. So welcome back all the dear students. So we'll resume our class. Welcome back. So this I have given the link how to find out FU plate when the grade of steel is given. That is the FU. If they write FE 410, that is the FU. Okay. Okay. So break is over. So now time to resume the class. Okay. So in the link you see I have in the chart I have given the link to my other steel lectures. Okay. So when the marathon finishes, okay, today rest time, you have a lunch and then sit with those lectures. You will get more practice questions and I can guarantee you that most of the questions will be covered for your GATE examination. Okay, those lectures will be sufficient. Okay, chalo. So we'll study one important concept which can be asked in the GATE examination. It's a new thing, but students have not seen that. So let us start. As I told that when I discussed this compression members, okay, I told that in compression members, effective length and the design compressive stress they can ask. Now to understand design compressive stress, we'll understand a few terminologies. Then we'll go into code, that what code tells about the design compressive stress. Okay, let us start then. So before going into the design compressive stress, we'll see some few points like what is the slenderness ratio? The slenderness ratio is nothing but the effective length by the minimum radius of gyration. Minimum radius of gyration. Now, what is this minimum radius of gyration? You take any cross section. See, cross section can be a rectangular cross section, or a I section, suppose, or a T section, or an angular section. Any section can be possible. Just I am giving few examples. Suppose it's an I section or T, rectangular section. So we know that this is the x-axis. Yes, this is the x-axis. This is also the x-axis, right? And this is the y-axis. This is what? This is the y-axis. This is the y-axis, right? This is the y-axis. Now, ladies and gentlemen, yes. So there will be radius of gyration about x-axis. What will be that? That will be the square root of Ixx by area, right? And there will be a radius of gyration about y-axis. So that will be what? That will be root under Iyy by area, right? Now the minimum of these two means what? The minimum of your Rxx and Ryy will give me what? The R minimum, the minimum radius of gyration. Now ladies and gentlemen, you see this Rxx and Iyy. Common is A now and square root. So I can say, how I will get the minimum one? I can say this R minimum will be indirectly equal to how much? It will be equal to the root over I minimum by A. Yes. And in L effective, how to find out? We saw it is KL. It is KL. So I can say the slenderness ratio is nothing but what? It is KL by R minimum. It is nothing but what? KL by R minimum. Yes. This slenderness ratio. Now the next term we will understand is the Euler's buckling stress. Now what is the Euler's buckling load? But critical load, that was how much? That was pi square EI by L effective square. And this I will be I minimum. It can buckle about both axes, so I'll take the minimum one. Right? Now see, the stress will be what? This is the load, na? This is the load, the critical load or buckling load. Now the Euler's buckling stress, FCC, given by what term? FCC. That will be how much? That will be equal to your buckling load divided by area. Yes. So this I can write down as pi square E. Yes. Then your I minimum by L effective square, then A. You see, what is this term? This is R minimum square, na? Yes, you see this is R minimum square. This R minimum is root under I minimum by A. This is our R minimum square. So I can write down this as what? Pi square E R minimum square divided by what? Your L effective square. And this is what? Pi square E. I can write down, I can bring this R minimum down, and I can write down that your FCC will be equal to how much? It is nothing but pi square E by L effective by R minimum whole square. So this is, ladies and gentlemen, the formula for what? Euler's buckling stress. It is a formula for what? Euler's buckling stress. How to find out? Simple. You can find out the slenderness ratio. And I can say that your Euler buckling stress is inversely proportional to slenderness ratio, right? It is inversely proportional to what? Your slenderness ratio, or square I can say, but inversely proportional to slenderness ratio, right? Slenderness ratio is what? L effective by R minimum. R minimum we know how to find out. Yes, root under I minimum by A. L effective will be how much? K into L. That also we saw, right? So in this manner we can find out what? FCC. We can find out what? FCC. So everything is clear. Now code will introduce a few terms. So code introduce a term known as what? Non-dimensional slenderness ratio. What is this term? This is lambda, and this is root under Fy by FCC. Root under Fy by FCC. I will ask you very simple questions also. For example, if I say that, suppose I am saying that, you know, L effective is, suppose I am telling 2.5 meter. L effective is how much? 2.5 meter. Suppose I am telling 2.5 meter. And I am giving that R minimum I have found out, and suppose R minimum I am telling, suppose 62.13 mm. Okay. And E is given as 2 into 10 to the power 5 Newton per mm square. So first of all, can you find out the FCC? Find out FCC and give me. Chalo, come on, find out FCC and give me. Newton per mm square, find out FCC and give me. Chalo, find out. Sorry, find out FCC and give me. Find out FCC and give me. This will be pi square. See, pi square term is there. Pi square term is there, okay? Pi square E. Pi square E. Pi square E. Yes? E is 2 into the power 5. Divided by L effective is 2.5. I can express in mm. And R minimum is 62.13, and this is whole square. So how much you are getting, ladies and gentlemen? What is my calculator? So here it is, my calculator. When you have found out, so this is the value. Yes. See, if I ask you what is the slenderness ratio, what will be your answer? If I ask you what is the slenderness ratio, the slenderness ratio will be 2500 divided by 62.13, right? 62.13. That is 40.24, right? I am getting 40.24. 40.24, right? Because the ratio means both have to be in mm, na? Ratio means both has to be in mm. Yes, mm. Understood? Yes. Now, this is non-dimensional slenderness, which is different, huh? Different. Suppose I am telling Fe410. Whenever I say Fe410, that means what? Your Fu is 410 and Fy is 250. So tell me, for Fe410, what will be the non-dimensional slenderness ratio? Did you find out the value? Did you find out the value? FCC is how much? 1219.13, and this is 250. Give me the non-dimensional slenderness ratio. How much are you getting? Non-dimensional slenderness ratio. How much are you getting? Tell me. 0.453. 0.453 you are getting. Yes. 0.4, 14 point, you'll get less than 1. This you will get less than 1. You'll guess mostly you'll get less than 1 only. Mostly you'll get less than 1. Understood? So this, everybody is now clear about slenderness ratio and non-dimensional slenderness ratio. Everybody is clear? Slenderness ratio and non-dimensional slenderness ratio, which code refers to. Everybody is clear? If they ask you in the examination, you can easily find out, right? If they ask you in the examination, you can easily find out, right? Yes? And this can be 1 mark questions. These all can be 1 mark questions, 40.24. Very good. Now, this slenderness, taking this non-dimensional slenderness ratio, you can see this code gives. The code comes into picture, you see code. Lambda is equal to how much? It is written root under Fy by FCC. And FCC is how much? That is pi square E by KL by R. Yes, Euler's buckling stress, L effective by R. Yes. So these equations are given in code and we just saw how to use them. Nicely we saw. Let us go to the next term which code tells. The next term code tells is buckling class. What is this buckling class code mentions? Now there are 4 buckling classes. There are 4 buckling classes. Okay. Depending on the which type of section it is. Now section can be hollow section. Section can be solid section, right? Section can be built up section, right? Built up section, right? Built up sections. Built up sections means what? Suppose you are combining 2 angles, it's a built up section. You are combining 2 channels, it is what? A built up section. You have an I section, you are placing plates over top and bottom, built up section. So all the built up sections are categorized in what? Buckling class C. All of them are categorized in buckling class C. All the solid sections are categorized in the buckling class C. All the hollow sections are categorized in the buckling class B. Now I sections, yes, I sections can be, I sections only. I sections can be all A, B, C, D. It can be all A, B, C, D. Solid sections means what? 1 channel, 1 angle, rectangular, all T section, all these are in C. But I section can be all A, B, C, D. Now, the category in which it will fall, it's little complicated. So we'll not go into that how to find out the buckling class of an I section. It will be mostly given in the question, don't worry. Okay. So based on this buckling class, we assign a imperfection factor. We assign a imperfection factor to that particular column. Now what is this imperfection factor? See, when you're finding the buckling stress, you're assuming all theoretical conditions, right? That column is perfectly straight, it is homogeneous, it is isotropic, right? And I can say the load is applied at the center and the load is perfectly vertical. Yes. Now all these things are what? Idealistic, right? In reality, the column will have imperfections. Obviously, it will not be perfectly straight. Obviously, the load will not be exactly at the center. Yes, it will be little here and there, right? Obviously, there will be non-homogeneity. It will not be completely homogeneous, right? So based on that, okay, based on that, an imperfection factor is given to the particular column. So as per the buckling class A, B, C, D, yes, different, I can say, alpha or imperfection factors are given. And you have to remember these values. For buckling class A, it is 0.21. For buckling class B, it is 0.34. For buckling class C, it is 0.49. For buckling class D, it is 0.76. These values you have to remember. Okay, directly they can ask you 1 mark question. Directly they can ask you 1 mark question. Okay, very nice, everything is nice. So next thing, this buckling class we understood. Next thing is stress reduction factor. Now, we saw that buckling stress FCC. Buckling stress FCC. So this should be the design compressive stress, no? But code says no. This is not the design compressive stress because there will not be perfect conditions. So therefore code tells that the FCD will be equal to the Fy of that particular column, yield stress, divided by gamma m naught multiplied by a stress reduction factor. Multiplied by what? A stress reduction factor. And this stress reduction factor will depend on what? It will depend on FCC, it will depend on the non-dimensional slenderness ratio, it will also depend on the alpha. Okay, alpha means what? Alpha means what? Your imperfection factor. So code introduces this what? This stress reduction factor. So if you find out this stress reduction factor, you can find out the FCD, right? You can find out the FCD, that is very easy. Fy by gamma m naught into stress reduction factor. So the code gives the stress reduction factor as what? How much it gives? It gives the stress reduction factor as 1 by phi plus root under phi square minus lambda square. Now what is lambda? Lambda we saw is the non-dimensional slenderness ratio. That we understood also now how to find out. And also we saw how to find out non-dimensional slenderness ratio. Right? Now how to find out this phi then? How to find out this phi then? This phi is given by this formula. This phi is given by this formula. You see what is given? Phi is equal to 0.5. Okay. I will rewrite this formula in my way. 0.5. Lambda you will find out. Lambda square plus 1 plus alpha. Alpha you will get from what? Buckling class. Then lambda minus 0.2. This is phi. So once you find out phi, then what you will do? You will put in this equation and then you will find out the stress reduction factor. Now once you find out the stress reduction factor, you can easily find out what? The design compressive stress. The next thing is what? The design compressive stress you can easily find out. How to find out design compressive stress? That only we discussed, right? It's very easy. It is what? It is written how much? You see it is written FCD is equal to stress reduction factor into Fy divided by gamma m naught. Divided by gamma m naught. Yes. And obviously this stress reduction is reduction factor, right? So it will be less than equal to 1. If it is less than equal to 1, obviously this value less than equal to 1 means what? This value will be less than Fy gamma m naught, right? Yes or no? Yes. 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 Now, so let us revise whatever we have studied till now. Whatever you have studied till now, till finding the stress reduction factor, let us revise. So when you are finding all these stress reduction factor in FCD, the first step is what? First step is what? You have to find out FCC. How we are finding FCC? It was pi square E by slenderness ratio, L effective by R minimum square. How to find out slenderness ratio? L effective is what? L effective is K into L and R minimum is what? R minimum is root under I minimum by A. Yes, easy. Now second step is what? Once you find out this, you find out non-dimensional slenderness ratio. How to find out? Root under Fy by FCC. These two steps we saw, right? We solved question also. Now the third step is what? From this you have to find out the phi. Phi is what? Very easy. 0.5 into, you got lambda, na? The non-dimensional slenderness ratio. So do what? Lambda square plus 1 plus 0.5, no, not 0.5, alpha into lambda minus 0.2. Yes, easy. Now once you find out phi, you can find out the stress reduction factor. That is how much? 1 by phi, not phi square, phi, root under phi square here minus lambda square. Now once you find out this stress reduction factor in these easy steps, okay, you can find out the FCD as we discussed. Yes, very good. Let us solve one question. Let us solve one MSQ. Okay, this is an MSQ. Let us solve this MSQ to understand everything. So it's an I section. I told whenever they give I section, they will give you a buckling class. They will give you. Okay, whenever they give I section, they will give you the buckling class. If it is not an I section, na, suppose they give a built-up section. That means what? It is buckling class C. If they give, angle section, that means what? Buckling class C. Yes, you should remember. So is given, effective length is given 3 meter, yield stress is given, Fy is given, cross sectional area is given, A is given, Ixx is given, Iyy is given. For what? To find out I minimum, right? E is given. Euler's buckling stress is asked, FCC. Slenderness ratio they have given. Okay. Slenderness ratio means what? It's not non-dimensional one. See, non-dimensional difference. Slenderness ratio means that they have given what? L effective by R minimum, right? Then stress reduction factor and then design compressive stress. So let us find out everything, then we can easily solve this MSQ. First step, so we'll follow the steps. First step will be to find out the FCC. You wrote the steps. First step you find out FCC. Find out the FCC. FCC we know how to find out. Come on, find out the FCC. For that you have to find out R minimum, right? L effective is anyhow given to you, 3000 mm. Find out R minimum. R minimum will be how much? It will be root under I minimum. I minimum is this one, na, you see? Is I minimum, na? Yes. So 2193.6 divided by area is also given 74.85. So how much is R minimum you are getting? Tell me. R minimum 5.41 centimeter. You see it is centimeter, na? You will get in centimeter. 5.41 centimeter, that will be 54.1 mm. Be careful about the units. Careful about units, right? Now slenderness ratio will be how much? L effective by your R minimum is 54.1. Everything you should take in mm or centimeter, whatever. So how much you are getting this slenderness ratio? 3000 divided by 54.1. I am getting a value of 5513. Actually this is 54.13, na? So if you divide by 3000 divided by 54.13, I'm getting 55.42. I'm getting 55.42. So obviously this slenderness ratio is wrong. This slenderness ratio is wrong. It's given 61.42 wrong. Next step is to find out the Euler's buckling stress. You can easily find out the Euler's buckling stress. That is what? I can say your FCC. That is what? 1 second. FCC is equal to how much? Your pi square. It is pi square, don't forget. 200 power 5, right? The E is given this value. Divided by slenderness ratio, how much we got? We got 55.45 square. So FCC, how much you are getting? Tell me. If you solve this, how much you are getting FCC? 642.7, almost we can say 642.8 we are getting. We are getting this as this. Very good. That means option A is correct, na? That means option A is correct. Now to check the stress reduction factor, I need to first find out what? Phi, na? I need to first find out phi, because lambda we have got lambda, right? I got lambda. See 641.9 and 642, that minor variation in calculation due to the approximation, that is fine. So the phi value is what? Phi is equal to 0.5 lambda square. Lambda square is what? What is lambda, by the way? What is lambda? Lambda we didn't find out, right? Lambda is 250 by 642.8. How much are you getting? Lambda, how much are you getting? Lambda, how much are you getting? Now this is very important. They can ask in the examination, right? Now these things normally we don't find in the previous year questions, but they're asking nowadays. You're getting 0.624, right? Find till 3 decimals. 0.624, right? 0.624 you're getting. So 0.624 square plus 1, lambda square plus 1, plus your lambda minus 0.2. So I can say 0.424, na? Lambda minus 0.2 is 0.424 into alpha will be how much? It is buckling class B. So alpha will be 0.34. Yes. See, remember, for A 0.21, for B 0.34, for C it is 0.49, for D 0.76. This they might not give you. You should remember the alpha value. Alpha they might not give you in the examination. So phi how much are getting? Phi how much are getting? Phi how much are getting? 0.767. You're getting 0.767. Great. So now I can easily find out what? The stress reduction factor, right? I can easily find out stress reduction factor. That will be how much? 1 by, it is not 5 square, it is only 5. So 0.767 plus root under 0.767 whole square minus 0.624 whole square. So what is the stress reduction factor you are getting? We are getting 0.284. Yes. So that means in the MSQ, you can see that the stress reduction factor we are getting a right value. So that is correct. Getting this as right value. So this is also correct. Okay, correct. Right. Now coming to design compressive stress. What is design compressive stress? This stress reduction factor into Fy. Yes. This stress reduction factor into Fy. So 0.824 into 250. I am getting how much? 206. So this is also the right answer. Any doubt in this question? Any doubt in this question? Clear? Any doubt in this question? Clear? 206? Huh? Wrong. Have to divide by 1.1. Never forget to divide by 1.1. So this is wrong. Huh? No. See, we will not get long questions, but they will ask you formula, na? See, I will tell you. So, you have to divide by gamma m naught. I will tell you. I will answer Prasant. I will answer Prasant. Yes. So this value is how much? You are getting answer 187.27. This is the final answer. So this is wrong. Never forget to divide by gamma m naught. Now, ladies and gentlemen, our question by Prasant was that do we get this type of questions in your, like, when you are preparing for this, like suppose this session, will this session help for your state examinations or your SSC JE or your ESC? Will these sessions help or not? Let us discuss. Let us see from starting then. You see, in the examination they will ask you, okay, in the examination they will ask you maximum size or not in the state exams. Yes, they will ask you maximum size. Yes, they will ask you maximum size. Yes, they will ask you minimum size. Yes, they will ask you minimum size. Yes. Next, they will ask you to find out the effective throat thickness for different fusion angle. They will ask you in state exam. See, first of all, this is for gate. We have discussed for gate. What my point is that same questions they can ask in state exams or not. Yes, they will ask. They will ask you all these values, right? They will ask you values, right? They will ask you values. Then, you see this question. These questions they can ask in the examination, right? You see all this question. You see, suppose I am talking about this one, this equivalent shear stress formula. They can ask in the examination, right? In the TSPSC examination, they can ask you the equation, or they might give you FB and Q and ask you the equivalent shear stress, right? So the point is that they might not ask you lengthy numericals, okay, but the theoretical part, the formula will remain same. So they will ask you simple questions from this. They might not ask you lengthy questions, okay, but yeah, these sessions will definitely help you for state exams because directly they will ask you the formulas. Yes, or simple question, like suppose they will ask you that for grade 5.6, what is the ultimate stress of your bolt? Answer is 500. Okay, answer is 500. Okay, answer is 500. Yes, or they might ask you the find out the value of KB. Yes, find out the value of KB. Or they will ask you find out effective length. Yes, effective length they can find out, na? Like this question which we solved. This question which we solved can be directly asked in the examination. one in your state exams. So that's what I always tell, that if you're preparing for GATE, automatically you're preparing for all exams. Just for other examinations, you need not solve lengthy numericals. That I can agree. But the basic theory part will remain same. Therefore, you have to cover in this manner. Otherwise, without understanding, how much you can mug, right? How much you can remember? Yes. How much we can remember? Yes. So therefore, it's very important that we understand the theory properly, because theoretical questions, straightforward questions, they will definitely ask. And therefore, I am conducting many sessions. If you see, in the recent past, I have conducted sessions like top 100 MCQs for transportation, top 100 MCQs for RCC, yes, top 50 MCQs for your open channel flow. In those sessions, I discuss the straightforward questions which can be asked in GATE 1 mark or which can be asked in your state examination. Yes, therefore it's very important that we understand the concepts and then practice different types of questions. For GATE, we can say MSQs, little lengthy type of questions will be asked. And we can say but GATE 1 mark, it will be straightforward, right? GATE 1 mark will be straightforward. State AE exams will be straightforward. I can always say that the state AE examinations are nothing but GATE 1 mark questions. How many of you will agree with my this statement that your state AE examination, let that be TSPSC, MPPSC, UPPSC, yes, anyone, okay? So how much weightage? I have taken one session on TSPSC, there I discussed the last 2 years papers trend. So please see that video. In that I have discussed that how many questions were asked in that. Okay, so please do some homework also yourself. You can go and see. I don't remember for every paper. Okay, so everybody agree with me that the PDF will be available in the Telegram channel. The Telegram channel link is available in the description. In the Telegram you go. Okay, there Civil Champions group is there. Okay, there you go. There you join the Telegram group. The link is available in the description. Okay, the link is available in this. Let me search and give. Some students are like, sir, nahi mil raha hai. Let me search and give to you so that nobody will tell sir nahi mil raha hai. तो कॉपी कैसे करते हैं? हाउ टू कॉपी? कॉपी लिंक नहीं मिल रहा, देखा नहीं मिल रहा है उसको डिस्क्रिप्शन में. नहीं मिल रहा डिस्क्रिप्शन, मेरे कमेंट में नहीं, डिस्क्रिप्शन, गो टू डिस्क्रिप्शन. आई नो बाकी सब मिल जाता है, लेकिन वट एवर इज द काम का चीज दैट वी नॉट गेट. ओके, सो नाउ आई एम पेस्टिंग. हाँ, नाउ ओके. Now this is the Telegram group. Okay, join this Telegram group. This is our official Civil Champion Telegram group. When you go there, what you do? You go to files. In files you will get all the PDF. नहीं है, कहाँ नहीं है? Steel formula, most expected, many things are there. Okay, many things are there. You go to group, you will get. It is possible that you might get. It is possible that you might get after 1-2 days. Suppose today's session was conducted, you might get after 1-2 days. That much patience you should have. Okay, old sessions PDF is available. So today's sessions, it will might, I will download it, I will send it to the team. The team might upload after 2 days. Yes, because team is very busy. There are so many session. Okay, So many sessions are there, so many teachers, the team is really busy. So they might take 1-2 days. You also have patience, na? Okay. Sir, you repeat all still in this lecture. Entire still I'll complete. Entire still. Okay. Full still I'll complete. Okay. Then full geotech, full environment, full 5-6 days will complete the syllabus. 8th day you will, you'll get active nirvana and then you will directly crack it. Okay. We'll try to cover as much as possible and cover the most important portions. Okay. So have patience. I'll also give you the link of other steel lectures which I have taken. Cover them also. Okay. Have a patience. पेशेंस नहीं गेट क्लियर तब होगा ना जब आप पूरा पढ़ोगे. ओके अटेंड ऑल द सेशंस. आई विल गिव यू द लिंक टू अदर लेसन्स आल्सो. नाउ फोकस हियर. नाउ फोकस ऑन दिस लेक्चर. ओके फोकस ऑन दिस लेक्चर. हमारा माइंड मेनी स्टूडेंट्स आस्क मी सर व्हाई दिस इज प्रॉब्लम हैपनिंग विथ मी दैट ये वो. द प्रॉब्लम इज दैट नाउ दिस इज गोइंग ऑन. फोकस ऑन हियर. व्हाई यू आर फोकसिंग ऑन? ओके focus whatever is going on. When this is complete, we'll think of something else. Now your entire focus should be over here. Design of compression members. It is possible, tell me, it is possible na, that this year gate 2 mark questions will be asked from design of compression members only. Yes, and you attended this session. Yes, you attended. Please provide. Arey baba. That is available in the channel. In the channel it will be available. हाँ मिलेगा. Wait for some days. Wait ना. It was conducted 2 days back ना. जल्दी से हाँ चलो. और कुछ ऑर्डर मारना है पंकज. और क्या है? और क्या? डोसा मसाला डोसा, रवा डोसा, रवा मसाला डोसा, इडली, बड़ा, बन, नीड डोसा, पोलियोग्रे. और कुछ चाहिए तो मैं पूरा ऑर्डर मार दिया. प्लास्टिक लिसिस में चलो सर. ओके कम बैक हियर. सो द एफसीडी इज हाउ मच? द एफसीडी इज दिस इनटू एफवाई बाय गामा एम नॉट. ओके ये पढ़ो पहले. ये पहले पढ़ो. एग्जाम में यही आ गया और यही तुम नहीं बना के आए. कितना आ रहा है ये? व्हाट इज दिस? हाउ मच यू गेटिंग? 187.3 Newton per mm square. This is FCD, right? So now purlins are not important for gate. Purlins are not important for gate. Okay, not important for gate. Now see, so in this question we covered one of the most important portions of your compression members. Now I will tell you another thing. New thing I will tell you in compression members. New thing I will tell you in compression members. See. If you see this order, how we found out this thing? Now be very attentive about this session, okay? I am covering this portion means what? What is the meaning of this? There is very high chance that they will ask a question from this. So please focus here, okay? Please focus here. Now how we got into this FCD? See, this FCD we got from where? From stress reduction factor, right? And FY, right? For FY. Yes, from FY and stress reduction factor we got this. Now stress reduction factor I got from where? From phi and lambda, right? Yes. Now phi I got from where? From lambda and buckling class alpha. Yes. Lambda I got from where? Lambda I got from Fy and FCC. Yes. And FCC depends on what? L effective by R minimum na? Yes or no? Yes. This is the sequence I can tell. Yes. So can I say that this FCD which you have got, it indirectly depends on Fy and buckling class and your L effective by R minimum, yes or no? Yes. This FCD, it depends on what? It depends on Fy, yes. It depends on alpha. It depends on the L effective by R minimum, means the slenderness ratio. And therefore what code has done, code IS 800, for different Fy, for different alpha, mean different buckling class and different slenderness ratio, KL by R or L effective by R minimum, they have found out the FCD, and that is mentioned in the table here. You can see it is a, what is written? Design compressive stress means what? FCD for column buckling class B. Yes, for column buckling, there will be no lunch break. Directly there will be lunch finish. And then you will be given the video links of some more practice session that you will do after the lunch finish. Okay, now focus here. Focus here. What is going on? Focus here. यही तो है, अभी पढ़ाई चल रहा है, लंच ब्रेक कहाँ है? वी आर स्टडिंग एक्स, सर वाई कहाँ है? जब वाई पढ़ाएंगे सर जेड कहाँ है? फोकस हियर, फोकस, कीप योर ब्रेन हियर. Next comment I will ignore. FCD. Yes. So you see, for different Fy, I told na, for different Fy, yes, for different buckling class, right? For different buckling class, yes, for different KL by R, this is what? L effective by R minimum, right? For different L effective by R minimum, for different Fy, for different buckling class, yes, what has been done? You can see that the table is drawn by IS 800. They have done all the calculations and given this. So you can see our Fy was how much? 250. Buckling class was B. And how much we got our slenderness ratio? 55.42 now. 55.42 will lie between 50 and 60. You see, for Fe 250, this is the column, right? In this, you see 50 and 60. 50 and 60 are this one, 194 and 181. Yes. So if you interpolate for 55.42, 55.42 will lie between 181 and 194 na? And therefore we got FCD is equal to how much? FCD is equal to 187.3 Newton per mm square. If you interpolate also, you'll get the same value. I'm not interpolating, but if you interpolate also, you'll get the same value. I'll highlight this again, little larger picture. You can see here, for 50 and 60, I'm getting for Fe 250. Yes, for Fy equal to 250. Okay, for Fy equal to 250, I'm getting these two values, and I can interpolate. Now, I can use this table when the table is given in the examination, right? If the table is not given, then I have to use the equations. So there are two methods to find FCD. There are two methods to find FCD. One method is what? Use table. Yes, but for that table has to be given, na? If given, right? If it is not given, that means the examiner wants you to use the equations. Or second is what? You use the equations. Use the equations. Understood? Now, let us solve some more questions. Compression members, there is a good chance they will ask in the examination. So please focus here. Find the design compressive stress for a double angle strut. Okay, double angle strut. Double angle strut is nothing but this. Double angle strut is nothing but this. Yes, okay. Is connected to a 12 mm gusset plate on two sides by welding. So this is a plate. Okay, on two sides it is connected by welding. Okay, and the cross section area is given. The R is given. R is same because it's a equal angle strut. So R is given, it is same. So I can say R minimum is directly equal to how much? Same, 30.9. So R minimum is given to you, right? Your L effective is not given. Now remember here, this is the strut of length 3 meter. Whenever there is a single bolting, remember the L effective for struts, okay, the L effective for struts will be equal to your L only. For double bolting, if two bolts are connected, the L effective will be equal to how much? 0.85 of L. Yes, and if it is welded, then L effective will be equal to 0.7 of L. 0.7 of L. Okay. Now for this, okay, 0.7 L. Yes. So now tell me, can you find out the slenderness ratio L effective by R minimum? L effective by R minimum, can we find out? Find out the L effective by R minimum. Find out L effective by R minimum. It will be 0.7 into 3000 divided by R minimum directly given to us. 30.9. How much are you getting? 68 around, na? 68 you are getting, huh? Getting 68, huh? 68 I can take approximately. 68, it will be ratio, not in mm, ratio. 68 ratio. Now see, table is given, you see, table is given. So when table is given, I can directly use the table and interpolate. See, 68 will be somewhere here. So it will lie between what? 168 and 152. Lie somewhere between what? 168 and 152. So I'll interpolate, let us see, let us interpolate. So at value of how much? At value of 60 and 70. So here it is 168, right? And here it is 152, na? See, if you know interpolation, then you can directly do, okay? If you don't know, I am doing for you, okay? It is at 68. You are finding at 68, okay? So somewhere over here, right? Somewhere over here, you can say this one, 68, na? So I can say this value is the FCD, yes? Now this FCD is how much? This is 152, so this is also 152. Now what will be this value? This value will be equal to, I can say it will be your slope will be how much? 168 minus 152 by 70 minus 60. This is the slope. And then this value is how much? This value is 70 minus 68. Yes. So this value is how much I am getting? This value is 168 minus 152. Okay, 168 minus 152 divided by 10 into 2. I am getting 3.2. Now I am getting this as 3.2. Okay, so I can say FCD will be how much? FCD will be equal to 152 plus 3.2. I am getting how much? 155.2. See, even if you are using the equations, you will get the same value. Yes, even if you are using the equations, you can try at home. Okay, you can try at home. Even if you are using the equations, you will get the same value. So they can ask a question like this, finding FCD using the table. But the thing is that for that they need to give the table, na? If they don't give the table, then you have to use equations. So I taught you both methods, right? I taught you both methods of finding the design compressive stress. Let that be using the equations or let that be using the table. So whatever is the question, you can easily attempt that, right? Tell me now, you're feeling confident about compression members or not? Tell me. Yes? Now in the examination, they might not ask you FCD. Always they might not ask you FCD. They might ask you some intermediate calculation. Okay, they might ask you some intermediate calculation just like this. So please solve this question and tell me what's the answer. They might ask you intermediate calculation, right? They have asked stress reduction factor. They have asked stress reduction factor. So find out stress reduction factor, okay? And suppose it is given that Fy is equal to 250. I am giving you the information, right? A factor, only factor is asked. Only factor is asked. We know how to find out the factor, okay? You see, non-dimensional slenderness ratio is given, lambda is given 0.757, and buckling class C means what? Alpha is equal to 0.49. This you have to remember, right? You can see that this question is not lengthy but intermediate calculations. Yes, and they can ask you a question like this also. Always they might not ask you lengthy things. Okay, from the same, lengthy thing, they will pick a small thing and they will ask you. Same happens with state services, same happen with, any examination. Therefore, you need to be thorough with the concepts. Yes, thorough with the concepts, and practice questions can be different for different examination. You have to practice more, 2 mark lengthy questions. For GATE 1 mark practice short questions. For ESE mains, more lengthy questions. For IRMS and civil service mains examination, more lengthy questions, right? But when it's come to state, small. But the thing is that exam might vary, but the concept is same, na? It's not that we use different IS code for GATE and different IS code for Telangana, different IS code for Madhya Pradesh, different IS code for Jammu and Kashmir, different IS code for Assam, different IS code for IRMS. Somebody tell, "Hey, this is IRMS examination, tough examination, so different code will use." No, same code. Everything remains same. Answer is how much? 0.7 you are getting? Yes. First you find out phi. Phi will be how much? 0.5 into lambda square plus 1 plus alpha into lambda. How much you are getting this phi? Phi how much you are getting? Phi how much you are getting? Phi how much you are getting? 0.923. Okay. Then when you are finding the station factor, very easy. It is 1 by, you see, it is phi, phi plus root under phi square. See, small question, but you see concept is same. Okay. 1 by, this is 0.923 plus root under 0.923 square minus 0.757 square. Yes. So how much you are getting? You are getting this as 0.65. 0.7 you are getting. 0.69 something you will get. So 0.7. You see, not a lengthy question. You see, two questions I solved now. Two questions I solved from compression members. You see, they are not lengthy now. You see, they are not lengthy, but they are conceptual. They are conceptual, right? 0.769 above, we are getting 0.69 something, na? Okay. Next. Let us see the next, that is column base. That is what? Column base thickness. That is column base thickness. You see this column base thickness TS. Okay, this column base thickness TS. How to find out this column base thickness? The code gives a direct formula. Means what? Here we put a steel plate so that the concrete below it, the pedestal concrete below it, doesn't fail in bearing. So this column base plate thickness is given by the formula. You see, the formula I will rewrite. It is 2.5 W. W is the pressure on that particular column in the plate, into what? A square minus 0.3 V square, okay, divided by your Fy by gamma m naught. So this m naught goes top then. Means what? You see, 2.5 W, okay, the pressure, A square minus 0.3 V square, very nice, divided by the stress. Stress is what? Stress is Fy by gamma m naught. So this Fy by gamma m naught is, that is easy to remember, therefore writing in this format. Yes, and see this gamma m naught goes top, but I write in this format, square root of this. Now this is easier to remember, and whatever TS you get, it should be greater than the TF. Means what? The thickness of the flange of the I section column which you are using. Yes, it's a very straightforward formula, very straightforward formula. How will find out the W? The uniform pressure under the slab, that is very easy. The factored load P is coming P by the area of the plate. Yes, area of the plate. So that is what? The W, yes, pressure, and then rest things you can find out. What is this A and B? What is this A and B? You see A and B. This is the top view, top view. This is the top view. So you can see this is the column I section. Normally we take I section, column, okay, and then the plate is below it. Okay, so this A and B are the projections. You can see they are what? The projections. Yes, okay, they are the projections. So we can easily find out. Now this we can easily find out. See, suppose I am telling that column is having size of 600 and 600. Suppose I am telling like this. Okay, and suppose we have an I section. Suppose I section is like this. Yes, I am telling that this I section is 300. So telling 300 mm. Then can you give me what will be A? Can you give me what will be A? This projection A. What will be A? Tell me. What will be A? Tell me. 150, very easy. 600, because this is also A, na? So 600 minus 300 divided by 2. That is how much? 150 mm. That is 150 mm. Very good, easy, nice. Thanda. Okay. So now let us solve one question. Let us solve one question to understand this better. This question they might ask in the examination. They have recently also asked. Might ask in the examination. A slab base of 500 into 500 means what? This will be the plate size. Is provided below a column. This column is an I section. ISHB means what? B for beam. But beam means what? Actually it's an I section. IS Indian standards. Beam means B means it's an I section actually. Okay. And this is 250 means this is the size. 250 means the, you can say this is 250. When they write 250, H for heavy actually. Okay. And 250 means this one is 250. Okay. So thickness of flange is also given to cross check finally. This is the thickness of flange TF. And then the width of the column flange is given 250. This is also given 250. It's also given what? 250. Okay. And then the design column load is given 2000. And the yield strength of steel is also given. Fy is given. The thickness of the base slab. It's very easy. First of all, you have to find out A and B. So when interested in finding the A and B, you see this 500, 500. And this is 250. This is also 250 by the way, right? Okay. See, this flange will always be not 250. Here it is 250. Sometimes it might be 180, 200 depending on different circumstances. Okay. So now we can say here A and B will be same. How much? Tell me. What will be A and B here? Tell me. What will be A and B here? What will be the A and B here? Tell me. 125? Yes. It will be 500 minus 250 divided by 2. So 500 minus 250 divided by 2 giving me how much? 125 mm. 125 mm. Yes. 125 mm. Yes. Very good. So now you got your A and B. Now directly I can find out your TS. What will be TS then? What will be TS? Root under, you can see 2.5. What will be W? W is the load. How much is coming? 2000 kilonewton converted to Newton. Area is how much? Base plate area is 500 into 500. How much are you getting this? 8 Newton per mm square, right? 8 Newton per mm square. So W is 8. See, A and B are same, right? So I can say I can take A square common. So I can say 125 square. Then 1 minus 0.3 B square. Na? So 0.3 is there. Divided by Fy. Fy is 250 by gamma m naught. Straightforward formula. Yes. So therefore, if you know this formula, you can easily solve this question. Answer this question. How are you getting? 31.02. 31.02, almost 31 mm I can say. And whatever TS you got, it is coming more than your TF. TF was some 13 point something, na? TF was 13 point something, or 9.7. It was 9.7, yes. It is coming more than that, so it is perfectly fine. So if you can ask a question on this, chances are there because column base is part of column actually. And very easy formula, very straightforward formula you can do. Let us go to the next thing, that is what? Beams. In beams, first of all, they can ask you questions on how to identify plastic, compact, semi-compact and slender section. Then they can ask you laterally supported beams, then laterally unsupported beams, and they can ask questions on web crippling. Now unsupported beams are looking a little complicated, so chances are less. So today we'll see how to solve questions from laterally supported beams, having the maximum chance to be asked in the examination. So we'll see what? Design bending strength of a laterally supported beam. Now laterally supported beam means what? Normally we take I section, okay, as the beams. For beams we took I section. Laterally supported means the top flange is embedded into concrete or it is supported by any means. This is what laterally supported beams. It is also known as laterally restrained beams. Supported means what? You can see it is restrained. Yes, laterally restrained or laterally supported. Okay. In this, how to find out the design bending strength? Design bending strength means MD. What is the design bending strength means? The design bending strength means that how much bending moment I can apply on the beam without failing it. That is very easy. I've also explained a few lectures before. That is very easy. How? This design bending strength is nothing but the moment of resistance or the moment carrying capacity. Let me switch on the AC now. Okay. Okay. The moment carrying capacity. The moment carrying capacity. Or the moment of resistance. Now, how you find out the moment of resistance? The strength of beams. If you remember strength of beams, which you studied in your strength of material, that is how much? That was the section modulus into your yield stress, na? Yes or no? That was section modulus into yield stress. Section modulus into yield stress. Here we'll introduce the factor of safety, gamma m naught. Yes. See, this strength of beam is what? Strength of beam is what? General equation is what? Your section modulus into yield stress, right? Here I'll introduce the factor of safety. Very easy. Yes. Now, if it is a plastic or compact section, if it is a plastic or compact section, then what will happen? The plastic moment capacity is developed. So this equation changes to what? Fy Zp by gamma m naught. Easy. Yes. And when it is semi-compact, then the plastic section, plastic moment capacity is not developed. So this remains what? Elastic. So Ze by gamma m naught. Yes. Very easy. See, so easy, na? Easy. Very easy. Equation is very easy. This is the elastic modulus, that is the plastic modulus. This is the elastic modulus, and this is what? This is the plastic modulus. This is what? Nothing but the plastic modulus. Yes. And this is what? This is the gamma m naught, which is, by the way, how much? 1.1, right? You should remember. So, very easy equation. Now let us see how the code tells this thing. So the code will tell little beautiful thing. So code tells in a very complicated way. I told you in a simpler way. The code tells in a very complicated way. The code tells it is what? You see, it uses beta b Zp into Fy by gamma m naught. And then what the code tells? The code tells that for plastic and compact, it is your 1. If for plastic and compact it is 1, then this equation changes to simply what? Zp Fy by gamma m naught, na? Yes or no? Yes. If it is 1, and that's what I told before also, right? Now they are telling that if it is semi-compact, it is Jd by Zp. This beta p is Jd by Zp. So if you multiply in this equation Jd by Zp, what you will get? You will get Jd Fy by gamma m naught, na? So indirectly they are telling the same thing which I am telling, but in a very beautifully complicated way. Yes. So if you see, they are telling this thing only, na? Yes. They are telling this thing only, but in a beautiful complicated way. Okay. So, nice. Let us solve one question. That's what kind of question they can ask in the examination. Okay. Let us solve one question. Cool. Let us repeat this animation. Series. Design. Okay, so this is a beam given. Okay, it is written that it is semi-compact. Section is what? Semi-compact. If section is semi-compact, so tell me what I will use, JD or ZP? Semi-compact, JD or ZP? JD or ZP? Semi-compact, JD or ZP? JD. Very good. So the equation will be very simple. It is what? JD Fy by gamma m naught. Very straightforward question. Very straightforward question. They will ask you straightforward things only. We are just complicated. हमारा माइंड कॉम्प्लिकेट हो गया है, पता नहीं कैसे हो गया है, बट हो गया है. ठीक है, हम मानते नहीं है. सी, if you are complicated, na, suppose how many of you feel that your mind has become little complicated? How many of you think that your mind has become complicated? Please write in the comment section. How many of you think that your mind has become complicated in the last few years? Or it is becoming complicated? Or complications are developed in your mind? Or external factors are complicating your mind? So I have a solution. I have a solution for all of you. The solution is listen to people who are simple. Listen to people who are simple like me. I keep things very simple in studies, in my life, in my personal dealings, in my professional dealings. I keep it very simple. I keep it very simple. If you see my teaching also, I teach in a very simple manner. So, if you want to be simple, just follow what I am telling. So today whatever I have told, just follow that. Surrender your mind. Don't trust your mind. Your mind is cheating you. Don't trust. I am telling the correct thing. I am 100% telling the correct thing. Follow whatever I am telling. Just do that. You will be immensely benefited. So whenever you are complicated, then listen to someone who is very simple in his mind. Okay? That is, better option than, trying to make your complicated mind simple. So better it stays complicated. See, your mind is different from you. You should understand that you are not your mind, right? Your mind is different from you. So let the mind be complicated. You don't listen to him or her, okay? You don't listen to your mind or heart. You listen to me. Your mind tells something, you tell your mind. Hey, mind, Sahu sir told me, Satyajit sir told me to do this, I am do this. Okay, tell the mind like this, okay? Tell the mind like this and do whatever I am telling. The mind will tell you something else, something, no. Why only compression members? I want to study gantry girder, I want to study plate girder, I want to study, I want to study how to find out the buckling strength of a bridge in Arunachal Pradesh. Okay, there are people who are teaching buckling strength of pata nahi kya in somewhere, pata nahi kya chal raha hai. Okay, so that time tell your mind, no. This much I will study nicely and I will go to the examination. Okay, so now whatever portions, not only me, other teachers, whatever they are teaching, complete that portion and go. See, try to understand. What happens, this is the syllabus. You might have completed this much. Yes, you might have completed this much, but your mind will be craving for this. Your mind will be craving for this. Na, it happens or not? Arey wo nahi hua. Arey ye hua na. This is complete. If this is complete, focus on this na. Now there is no time to focus on this. This should have focused before 7 months, 8 months. Now there is no time. Leave this. Leave now. Now there is no time. So whatever you have completed, complete that properly. Whatever you have studied before, complete that properly. Focus on the portions which are covered. Focus on the statements, the suggestions given by the different teachers. Okay, and then do this. And certain things which you are not unable to do, ignore that. Okay, otherwise whatever you have studied, many people tell na, sir, whatever I studied, I forget that also. And it will happen now, obviously, because when you are studying X, you are worried about Y. You are studying Y, worrying about Z. You are studying Z, worried about A. Studying A, worried about I section. I section has come into picture. Let us solve this question now. Okay, so now you are solving I section. So focus on here only. Focus, keep or focus here. Okay. Semi-compact means ZD. Fy is given. Fy will be how much? Fy will be 250 Newton per mm square. Okay, very good. Gamma m naught, we know it is 1.1. I have to find out the ZE. How we find out ZE? The illustration model is that is I by Y max. Okay. Now if you see this I section, if you see this I section, I can easily tell that, you see this is given 800 mm. From here to here it is given 800 mm. Total depth is how much? Total depth is 832 na, you see. Total depth is 832. So Ymax will be 416 na, yes or no? Ymax, you see this is Ymax na. Ymax is 416. Ymax is 416. Yes, Ymax is 416. Very good, nice, beautiful, very good, nice. Now how to find out I of a I section? That is very easy. If you see this I section actually is a big rectangle and subtracting two small rectangles, right? Yes, this small rectangle, this small rectangle. So I can say the I will be equal to, the big rectangle is how much? 20832 na, 20832. So I can say B d cube by 12. The small rectangles, if you combine the small rectangles, this depth will be 800, yes, and total width will be how much? You subtract this 16, so 216 is 184, right? So combined this two rectangles subtracting, that is how much? I can say 184 into, because it's 16 na, 184 into your 800, right? 184 800 cube. So can you give me the I value you are getting? I value you are getting for this? How much you are getting? 200 into 832 cube minus 184 into 800 cube divided by 12. I am getting 10 to the power 6 na. Divided into power 6. 1748.1728 into the power 6. Very good. I got this. Then I need what? ZE. ZE will be how much? Divided by 416 then. Divided by 416, I am getting how much? 4.2 into 10 to the power 6. Getting this value na, 4.10 to the power 6 mm cube. So when I am finding the design bending strength, I am finding design bending strength. Very easy. Very easy. The design bending strength will be equal to ZE, that is 4.2 10 to the power 6, yes, into Fy divided by 1.1. You see this is how much? This is in Newton mm. So I'll convert it to Newton mm, Newton meter. So I'll divide 10 to the power 6 to convert into Newton meter. So this get cancelled. I get how much? 250 into 4.2 divided by 1.1. I'm getting a value of 954.54, right? I'm getting almost 954.54. That will vary, it will be in range. Some people will get 955, that depends on what approximations they are taken. In the examination they will give you a range, so need not worry. You see this short question, right? You see, you can easily solve this kind of questions, okay, if they are asking in the examination. Okay, very good. So that ends our session, okay. Sir, I might be thinking, sir, what is that? Okay, that ends our session, but not the work for you. Not the work for you. Okay, so I have taken this lecture of plastic analysis for collapse load. Okay, this lecture is available. I'll give you the links now. Okay, I'll give you the links now. Okay, plastic analysis, Satyajit. See, if you can Google search also you will get, but I will give you the links because students might be, you know, this is 1 hour 52 minutes video. You can watch in 2x. Okay, 1 hour 52 minutes video. You can watch in 2x or 1.5x as per your this. I have covered almost all the important collapse load conditions which you can ask in the examination. So this lecture you will complete. I'll give you the link, don't worry. And then I have completed this lecture on shape factor of plastic analysis. The shape factor is also around half an hour, but all the important portions are completed in this. So you can refer these lectures. Yes. Also, ladies and gentlemen, I have taken these three videos. I have taken these three videos where I have solved many questions of steel structures. Recently, last month I have taken. Okay. So here I have solved, MSQs I have solved. But in formula, I have not only discussed formula, but I have solved questions. Especially I have solved question from tension members. Especially I have solved question from tension members, bolted connections, okay, bolted connections. I have solved questions from bolted connections. Eccentric bolted connections, I have solved some questions here, which I have not discussed in this particular video, okay. So these videos is your rest of the day work. And tell your mind, how sir is telling, I will do that. Don't use your brain now. Whatever I am telling, just do that, okay. So these 5 lectures, apart from that, I have solved objective questions for steel structures. This is 1 mark gate questions. For gate 1 mark, I have solved this, okay. This session I have taken, okay. 30 questions I have solved here. And then also I have solved riveted. I have not done, only bolted done, because in gate examination only bolted connection is there. So to focus on only bolted connections. So here also I have solved objectives, okay. So these sessions are 30 minutes, 40 minute sessions, okay. So all this will be your rest of the day work. So I will give you the link now. I'll give you the link now to all the lectures. I have arranged these lectures in a, we can say I have arranged this lecture in a, what we call that, Excel sheet, okay. I have arranged this lecture in an Excel sheet. Now I will tell the reason why I have been doing this. I will tell you, okay. You will think that why sir अभी पढ़ाओ नहीं, ऐसा नहीं. Why I will tell you, okay. I will tell you the reason, okay. I'll first share the link and then I will tell you the reason also. Let me share first of all, okay. So this is, you see, this is the link of all the lectures. If you open this link, you will get 5-6 lectures, okay. There all these are covered very nicely things are covered, okay. And I have not included the PDF. The PDF also I will put in the side column. The PDF also I will put in the side column, so that if you need the PDF also, it will be available for you. And still if you are facing any issue, you can message me. I will then tell you what to do, okay. So you can message me, I will tell you, okay. So now the rest of the day, now have a break, lunch break, go. After that come back, open this sheet, okay. Sheet, just sheet, sheet, okay. SCSSHEET, okay. And then, okay, and then start covering the lectures. You can cover in more speed because that is recorded lecture. Recorded means I have taken that live only, but now it is old lecture na. So you can cover fast also. Now why I am doing this thing? See, I am a human being. So after 4 hours, my mind freshness also goes away. Now I am not fresh. I will admit that. I will switch on the helicopter AC. Okay. See, now I am not fresh. See, morning when 10 o'clock I started taking the class, okay, then I was fresh. Now I am not fresh, okay. After 3-4 hours of lessons, I am not fresh. But those lectures which I have taken, yes, these lectures which I have taken here, you see, all these lectures, when I took that time I was fresh now. Therefore, I have given my best in these particular lectures. My best content is available in these lectures. I have taught in very nice way. So please refer them. If you solve this much also, there is very good chance that you will get full marks in still. सर स्टार्ट कब क्लास होगी वापस? और स्टार्ट ही नहीं होगी, हो गया, खत्म. आज का खत्म हो गया. अब ये है आपका रेस्ट ऑफ द डे क्या करना है वो समझा दिया गया है, ठीक है. आपको रेस्ट ऑफ द डे क्या करना है, ये सारे लेक्चर्स देखने हैं. ये सारे लेक्चर्स का लिंक दे दिया गया है ऊपर, ठीक है. आराम से बैठ के लेक्चर्स देखिए. यही तो प्लास्टिक एनालिसिस है. ये तो प्लास्टिक एनालिसिस का सो गया था बीच में क्या? अरे प्लास्टिक एनालिसिस है, देखो, दिस इज रिटन प्लास्टिक एनालिसिस. प्लास्टिक एनालिसिस, दिस लेक्चर इज अवेलेबल इन द लिंक अबव. ओके ओके, पीछे चला गया था, ठीक है. अभी आगे आ जाओ, ठीक है. सो दिस लेक्चर लिंक इज अवेलेबल इन दैट थिंग. आई विल अगेन शेयर. वो पीछे चला गया, मैं फिर से शेयर. टेंशन नहीं लेने का, ठीक है ना, पढ़ने का. Okay, टेंशन नहीं लेने का, टेंशन देने का, like I give to many. Okay, so don't take tensions. Okay, study nicely now. In this, all these lectures are arranged. In this 1 hour 52, I have covered all the collapse loads. Nicely, you can understand all the collapse load. Okay. If you face any difficulty, you can message me. Okay, no problem. Safe factor, collapse load. Okay, tension members. ठीक है ना, tension members. Okay, everything I have covered, and whatever things I have taught now also, some additional practice questions you will also get. Like today I taught you shear strength of bolt and this bearing strength of bolt. I have solved more question. No, 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 no. I will not teach. So now I will come back to the schedule then. Okay. So everybody understood what to do. Everybody understood what to do. Okay. What to do? Everybody understood. I will again share the link. Okay. So all the lectures are arranged nicely. Enjoy the rest of the day with these lectures. Okay. And any doubt, you send me the message. Okay. And tomorrow we have Richa ma'am taking environment. So this is the schedule. Okay. I will come back. I am going for holidays. Now I'll go for holiday. I'll come back on 13th and 14th. I will cover building material, construction management and RCC. ठीक है. So I'll cover building material, RCC and this. So if you are liking my lectures, if you want to see my other lectures, you can message me. I will send you the link of the Excel file of all the lectures of other subjects also. I will do that. Okay. So by that time you attend all these very important sessions are coming up. बाप रे बड़ा खतरनाक subjects आ रहा है. Environment 12 marks, Geotech 13 marks, Fluid Mechanics 4-5 marks, Surveying 4-5 marks, Structure 4-5 marks, Hydrology Irrigation 4-5 marks. Okay. So very lot of important topics are coming up. Till that time you enjoy. Okay. And then you come back, then you will attend. And after 16th, I will be conducting engineering mathematics. Okay. After 16th, अभी आप मैथ्स का टेंशन नहीं लेने का. One video I have taken for vector calculus that is available in the playlist. So attend that lecture if in free time you want to attend. I have already taken this. Now other topics, all important topics. Important word is very important. Important word is very important. So important topics I will cover of engineering mathematics. That will cover from 17th to 27th of January. Okay. So thank you very much. Okay. Have a wonderful day with all the lectures. Okay. Please go to, I will finally paste again. Okay. I will finally paste the lecture again. Okay. So now have a break, 1.5 hours break you can take. And then first you complete plastic analysis. First you complete plastic analysis because that is very important for your gate examination. So 2 videos are there, plastic analysis, collapse load and shear factor, cover that 2 lectures. And then after that, other sessions, when you are free, you can watch today or any other time. That I think will be acting as your good. Thank you very much then. Bye bye. Nice. Okay. So tomorrow, Richa ma'am will take environment. So please attend that session nicely and cover everything. Thank you very much. Bye bye. Bye bye. 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 And don't listen to mine. Listen to me.